I'm going to present you. Just let me figure that thing out. Oh, okay, it works. Nice. I can go back. Yeah, perfect. Okay. So I'm going to present you the result of a research that has been done in collaboration between Yale University and my company, Lagrange Labs, that is related to how to build a double action mechanism for efficient resource allocation in the context of a prover network. So let us unwrap that a little bit. The general plan, to put it in more layman terms, is to find a mathematically sound way to broker fair and mutually benefiting conditions in a market between sellers and buyers. And in this very specific case, given that my company is a company geared towards ZK proofs, but we do not want to do the proving ourselves because we are not AWS or GCP and we don't have any special hardware capacities. The goal is to basically put in a relationship between sellers, so people who have a lot of compute power and are ready to take on proving tasks, and buyers, which are clients that do want to generate ZK proof for whatever use case they are using. So this is a theme that has been quite widely explored in more traditional financial systems when it comes on to, for instance, market making or basic auctioning. But in this case, we have a very specific slight difference that is actually not really well covered in the literature. And this is a fact that for the clients, all of their offers are all or nothing, right? Like for instance, on the stock market, if you want to buy 50 shares of a given society at a given price, you would probably accept if I can only give you 45. But in this case, if you want to generate a ZK proof and you need a given amount of compute cycles, if I'm saying, okay, I can only provide you 95% of them, you're not going to accept the deal because you want to finish the proof. You don't want to have the computation stop in the middle. So this is where we are differing from the more classical application on theoretical exploration of the domain. So now to dive down a little bit deeper in the application of this system in our company, we are running a couple of prover networks that are running different proving systems for different applications, but all of them are following the same global organization. So we have clients. Clients are the people that want to have ZK proof run and proved and returned back to them. We have operators. Operators are entities that are running one or more on many computers, and they want basically to make a margin between the cost of exploitation and the money that they will get when they run the proofs. And finally, we have the auctioneer, and the auctioneer is ourselves. So we basically want to nurture the ecosystem that we developed, and we want to put these people in a relationship so that they can use our ZK systems. So this is the global overview, and now we will focus quite closely on how to have clients putting up offers with for a given amount of computation at a given price, and operators proposing proving computational power at another given price, and how to match between them. So to start with a little bit of definition, there is like the pentafecta of a good auction system that has been defined in the literature. And for a proving system to be efficient and to be smooth and for everyone to actually have an incentive to run into it, these 5 criteria have been retained. So you have the truthfulness. It means that people basically taking part in the system do not have any advantage into lying. So it doesn't make any sense as you don't get rewarded, for instance, as an operator to overestimate your running costs. You have the weak group strategy proofness. Basically, if you are trying to conspire with a group of people to act on the prices, there will always be at least one person in the group for which it is more advantageous to leave the group rather than to maintain the clique and to maintain the conspiracy. Then you have welfare maximization. Basically, we want to extract the maximum amount of value for everyone. So we want to find the global maxima of value generated, which is basically paying as little as possible for the clients and getting as much money as possible for the operators. Then there is a weak budget balanced criterion, which is saying that the actioneer does not lose money, of course, because otherwise, if you're losing money, you're not really running a long-term system. And finally, you have the computational efficiency, which is not really a criterion, but more a limitation of the real world, which means that the algorithm must run in a polynomial time, which is a fancy way of saying that you cannot really find galactical algorithms that would take months or days to find the optimal solution to a given auction. That wouldn't be realistic. Now, the thing is that what the theory is headbutting against is that kind of problem, so the double auction mechanism problem, is actually very similar, and in some way, very similar to the knapsack algorithm, knapsack problem. So what is the knapsack problem? The knapsack problem is what you hit when you are trying to fit all you can in the hand luggage that you can take on the plane, right? So you have a given luggage, you have a lot of stuff of variable sizes and weights that you want to take with you on your trip, but you are limited to, 15 kilogram on a small carry bag. So what do? You have to find the optimal solution to take on as many items as you can while respecting the limitation of the knapsack. And this is a problem that is unfortunately NP complete, which means that basically if you want to find the optimal solution, you have to try every single other solution. So when you have 3 items, that's pretty simple. When you have 45 of them, your combinatorial complexity is already through the roof. And so that kind of problem is not really solvable on a global maxima in a reasonable amount of time as soon as you are living like the most basic of precincts. So what we are doing, because exactly the same limitations are applying to our system, which is some kind of a very complex knapsack. So what we are doing is that we will be basically loosening some of the criterion, and we will reach what I would call a tetra-and-a-half vector of a good auction. So we are keeping the same criterion, but we are going to change some of them. So for instance, the welfare maximization, which is the hardest one, instead of maximizing the value that is extracted from the auction, we are just going to make sure that it is positive. And too bad if that's not the optimal solution, but at least we will have a solution where everyone will be making money on the system as a whole will behave in a probably not optimal, but at least acceptable way. So following that, the global strategy that has been established is to define a parameterized family of algorithms. So basically, you take building bricks, and you will be building, according to a single recipe, an algorithm from all of these bricks. Then you will prove that this algorithm recipe is actually fulfilling the criterion of the tetra-and-a-half vector of the good auction. You will choose parameters that are adapted to the application, so you will change the little building bricks before running your recipe. And finally, you just have to cook that thing, and you get what you want for your use case. So here we are going to describe what are the parameters of the family of algorithms that we define in this paper. So the first thing that you need is a ranking that has to be consistent and monotone for clients and provers. So what this part of the algorithm do is that it will rank the offer from the provers and the offer from the clients in a way that will be used then by the other pieces of the algorithm. Then you must have an asymmetric composition rule, which will determine whether client-prover match, so whether a match between a given request for proof and a given offer for computation is actually useful or not. So for instance, you need to be sure that the computational power is bigger than what is required to run the proof. You have to ensure that the prices between the offer, between the bid and the offer are compatible, and so on and so on. You need an asymmetric composition between the clients and the prover. So this is the part of the algorithm that will be generating this matching to be accepted or rejected by the composition rule. And finally, you need a payment rule, which will be there to price the matches between the proof request and the computational power that has been offered by the clients. So in our specific case, the rule that we are using is that we are ranking the proof offer in a decreasing order of profitability for the for the prover, so that we are running first the one where the, let's say, cost by cycle is the highest. And for the prover, we are ranking them in decreasing order of computational power. So this way we have the biggest one running first and the smallest one at the end to take anything that couldn't fit in the biggest one. So what are the applications for that? So the problem, of course, is that this is a very nice and very fine theoretical design, but then you hit your head against the wall of reality, and this is exactly the thing that happened here. So for instance, the paper only defines what happened in a single round of an auction at a given point, but when you are running a prover network, then the thing must run in a continuous way, right? You have always incoming requests for proof, and you have always incoming machines on the operator side, or machine leaving, and so on and so on. So you need to introduce a dimension of temporality, which is not necessarily something that is trivial to do if you want to maintain the characteristics of the algorithm. So this is something that we are working on closely with our mathematical department. You have to, in some way, only let truthful partners within the double auction. So for instance, you don't want people who will provide you with computational power that will fail, or that will take a very long time to run proof, or that will have a lot of more technical issues. And this is not even talking about people that are actually trying to damage your model, but this is another already another question. You also need to implement sometimes client-specific criterions, because when you are interacting with other companies, of course, other companies won't always have a whole set of requirements that they will reveal to you in due time, and they will want, for instance, to favorize some kind of operators because they may have previous deal with them, or in any way. You have to, let's say, add all of this meta information within your system so that you can, let's say, satisfy the two parts in the business deal. You also have to discriminate between heterogeneous hardware. This way is a very big issue, of course, because in the real life, computational cycles are not all the same, right? If you have a proof that can either run on a GPU or a CPU, and you have proof that can only run on CPU, and proof that can only run on GPU, how do you balance all of that to maintain all of these criterions? Because, for instance, you cannot if you were to have completely separate queues for CPU and GPU, you probably would end up with some unoptimal use of the total compute power. If you mix everything together, then do you want to prioritize dual machines, or do you want to prioritize GPU machine or whatever? I mean, that's a very complex set of issues that are also quite interesting to solve, I would say, and sometimes, unfortunately, add another combinatorial factor to the final complexity of the algorithm, which ends up with something being close to, well, virtually unsolvable in a reasonable amount of time. And once again, you have to rely on heuristics to actually be able to address that kind of issues. So yeah, that was it. Thank you for your attention. I hope this gave you a glimpse on the technical difficulties and the challenges that come from taking a pure research paper and actually porting it over to a final product. And thank you for your attention.
Thanks for this talk, Franklin. So this gave you an introduction of a research paper on a double auction new model. Do we have any questions? We have some time left in case you have questions. Shoot it away. No worries. Okay, we'll discuss and dive into questions. I'll lead the session in a moment in the TE Unplugged. So we have now Tanisha on stage. So you please come on stage and set up your laptop. And while doing this, I'll give you an overview of what is planned next. So Tanisha will give us a talk about reputation systems in the context of proof-of-stake validation. So to enhance and also counterfight centralization when it comes to validators and delegates. And after this talk, Franklin and Tanisha will join us on stage again to dive deeper, right? To look at, okay, what are we seeing in terms of developments in mechanism design, in terms of implementation challenges, in terms of design patterns. And so make sure to stick around for Tanisha's talk and also for the TE Unplugged session right after. All right, now let's check if the slides are okay. Let's get them on stage. Can you give us some info if everything is running smoothly and if you can get Tanisha's slides on stage for those who are running the live stream? Okay, give us a moment. We'll sort it out. Tanisha, maybe you introduce yourself meanwhile.
Of course. Hey, everyone. Thanks for being here. I am an independent consultant. I work with different protocols on different problem statements.
Can we help?
Mostly on governance and interoperability.
You're on.
Today's talk is going to focus a lot more on a mechanism, like one of the subsets of governance called as reputation, but applied to a very specific group, which is node operators, validators, and it jumps into a lot of numbers. So we'll see like different ecosystems, see how decentralized they are. We'll define decentralization very specifically, and hopefully I will get all of you to participate with me a little bit. So I will show you some numbers, and then I want you to start guessing what, how many rewards each node operator could be holding. And we'll see how good you are. But yeah, I'd love if all of you can interact and just shout back at me.
I think we are good to go.
Does it work? I can't hear you, sorry.
Okay. I'll be back in a moment. Thanks for the patience, everyone.
Maybe it's this. You want me to give you a PDF? I can do that.
This is the validator talk.
Okay, so it's the start.
Okay, we are trying to sort it out.
Okay, maybe what we can do is while this sorts out, I can try and get started. Does that work? It's perhaps for the good that we don't have visuals, so I get everyone's attention. Okay, let's start. My first slide actually reads something that I don't think everyone here is going to agree with, and that's fine. It says decentralization is dead. Everything we intended to do, we failed at. I know that not everything has to be decentralized. I also know that decentralization can be very tricky, very expensive, and perhaps very subjective. With that, in the next 10 minutes, I actually planned to take you folks through 3 Star Wars, the famous trilogy. It starts, Act 1 starts with the very famous A New Hope. Act 2 in the Star Wars trilogy takes us through, any guesses? Are there any Star Wars fans here? Yeah, it's essentially the Empire Strikes Back. Yes, and the third one is the JD is back. And so what we'll do is you'll see that theme playing out. A New Hope. Like, think about it. Why are we all here in the ecosystem? When we have to go out and defend blockchain, some of our arguments are about how decentralized is it. When I watched Vitalik's movie, the first screen that came was how there are these massive entities and centralized forces, and how it was supposed to be the new era of internet. It brought a lot of hope, where you didn't need these centralized, powerful middlemen to connect service providers and users. You just have a massive peer-to-peer network that could, be decentralized, could kind of have smart contracts, could work upon rules, and could facilitate large transactions. And we weren't being controlled by centralized dopamine hits all the time. Over time, what do you think happened to that? At the very core of our blockchain networks, the node operators, do you think they're sufficiently decentralized? Or are we recreating the same system that we had earlier? So let's actually get into the Empire Strikes Back. Let's take 5 foundations. I wish I could show you some graphs, but nonetheless, oh, great, we have it. Amazing. The wish comes true. Let me go back. This one? Does it work? I don't see it's changing, sorry. Okay. Going to jump right into the Empire Strikes Back, because that's where we were. Let's take a couple of random but very important ecosystems. Let's start with Celestia, right? There's 4 analyses that we did. Number 1 is a Pareto principle. What percentage of validators hold 80% of rewards? The second analysis we did is normalized rewards. So we said, how much does the lowest 50% hold? So if I had to put them all in rank, what would that look like? We did a dynamic mobility, which means you're not just looking at static numbers, you're also seeing over the 1 year. So I've taken the data of 2024 to 2025. Over that 1 year, do validators at the lowest rank actually move up top? Is there mobility in the network? And then fourth, we saw some classic economic inequality indicators, which is there's the Lorenz curve, the Gini coefficient. Do they also indicate some form of economic inequality? Let's look at some of the numbers. Pareto, apparently in Celestia, 27% of validators end up holding 80% of rewards. What about the lowest 50%? Unfortunately, they just hold 8% of total rewards. In fact, the top validator, Go, captures an extraordinary 27.25 of all normalized rewards. Now, rewind back a little bit. We started with A New Hope. We said we wanted to replace these massive centralized infrastructures and replace them with a more decentralized internet. That was the promise of the new internet. So how is it that this is better when fewer validators end up holding such a massive power over the network? We go into checking the economic indicators over time, and we see that The ideal, the orange line that you see, it's the ideal curve, right? That's what a normal system would probably look like, a more equal world would look like. But the yellow line that kind of sweeps through down to up is still, unfortunately, the state of inequality today, right? The Gini coefficient being 0.7, so the closer to 1 it is, the more kind of realities you'll see. Sorry, let me just pull up something as we move. Maybe. And then we have the quintile transition matrix. So that matrix is essentially kind of showing you how validators are moving from one quintile to another over the 1 year. And you'll see that there's barely any mobility. If there is one that's in the very top 20%, they continue to remain stagnant throughout the year. There's hardly any movement. This is what we call as the sticky wealth, where you continue to dominate your position of power for a long period of time in the network. Can it get any worse? What if we look at Polygon? What do you think is the state of art there? So we did the same analysis again, just anchoring back to everybody. Can I get some numbers? What do you think are like, if you had to answer Pareto, what percentage of validators at Polygon do you think are holding 80% of rewards? Random guesses. Just throw a number. Okay, 10, 19, let's see. Well, it's 16%, somewhere in the middle. They end up holding 80% of rewards. And what about the lowest 50%? It's absolutely like they're living off 2% of total rewards. Now, let me clarify some definition here. What do I mean by rewards? So this is normalized rewards. So you get block rewards for producing blocks. You get attestation rewards for signing checkpoints. It's a combination of both. But when I say it's normalized, it means that it's calculated over the period of active time. So let's say you joined 1 year ago, I joined now. Of course, I'm going to have lower rewards than you. So we normalize the rewards based on your active epochs in order to be able to compare apples to apples. Go on further, we see 6 validators hold half of the entire network rewards over time. What do you think about mobility? Do you think the lower validators are able to climb up over time? Let's see. The mobility index is 9.4%, which means year on year, a maximum of 9% validators tend to move up. And when I say move up by just 1 quarantine. So you're not going to see the bottom 50 directly go right up. So sticky wealth, Gini coefficient being just as bad, Lorenz curve showing similar patterns of economic inequality. And the bright line that you see, that's an indicator of people staying in their quantile and not moving up a lot. And that bright line is a thing to worry, because maybe we start systems with centralization. The promise was progressive decentralization. I don't think that's happening. What about dimension? Now, we have few examples, so bear with me. What do you think, throw numbers at me, what percentage of validators do you think are holding 80% of total rewards? Any guesses? Okay, can get worse. Well, it's still at the, you're seeing a very clear Pareto. You're seeing 10 to 20% validators holding over 80% of rewards. There is an example where it gets worse. So, hint, hint. Dimension has 12.2% of validators. The lowest 50 hold 2.5%. Again, really, really low. Shockingly, 2 validators hold nearly 60% of all rewards, and 10% command 3/4. When you design governance and you give voting power based on how much stake they hold, you have to be careful, because this is where giving one token staked is equal to 1 voting power can get dangerous really fast, right? Same, economic indicators show us really bad Gini coefficients. The bright line in that quantile transition matrix, if you remember, shows us that people tend to stay where they are. Finally, the final example, I'm not going to bore you guys too much, but here it is extremely shockingly low. 7.1% of validators hold 80% of rewards. The lowest 50 literally hold 0.5% of their normalized rewards. The top 10% validators in Chronos hold 90% of all rewards. I don't know if it can get more centralized or dangerous. And this exactly brings me back to the question, what are we really doing? If our goal was to create the new internet to replace these centralized entities, have we not now created a node system, operating system, that replicates the same traditional system in our real world? So what is the solution? I think we all understand the problem. This is where the return of the Jedi. We get into the third part, the final part, where we're researching something called as validator reputation score. Like the term suggests, it's a score that depends on meritocracy, right? It looks at three things. It looks at your attestation effectiveness score, it looks at your proposer effectiveness score, and it looks at your social effectiveness score. Now think of these as Lego blocks. This is not a one-size-fits-all, right? You could say, I'm gonna give 70% weightage to block production because the block rewards are much higher than attestation. And you could kind of give weightages of your choice. Social effectiveness score can be broken down into parameters that matter to you as a network. So if governance is important to you, that would be one of the social effectiveness score that you could incorporate. If diversity and reducing single point of failures is important to you, that could be your social effectiveness score. The goal is empower, recognize, and reward validators in a way that's fair, meritocracy-driven, and accessible. These are the formulas. Please let me know if you have any questions towards the end. I'm not going to get into the thing of it, but it can be used in three big applications. Number one, reward distribution. So we all need stake. Why do we need stake? Because if there's any form of security concerns, slashing can take place. So stake becomes security. But should stake be privilege, where if you have more stake, you get more rewards, thereby ending up dominating the network? Perhaps not. So reward distribution can be tied to reputation. Stake can exist for network security. It can be used for validator admission. And I have something very exciting to show you here. And third, it can be used for shared security orchestration. I'm sure a lot of you have been hearing about shared security, eigen, restaking, validator sharing. How do you do that? How do you decide which validator secures which network? Why not use something fair, like a reputation in that system? Has this been tried? Well, it has, in some sense. In Polygon, we had a validator admission framework that was stake only, which means that if you met the minimum stake criteria, you'd get a validator slot. We moved that to stake and reputation. So while there is a minimum stake, which is not very inaccessible, a lot of your admission criteria now is kind of determined based on your kind of reputation. We use experience score, expertise score. We look at your on-chain data to see how you've kind of validated in previous networks, and then determine it. What we found, over 12 nodes were onboarded using this admission framework with 0 performance issues and high network health. So I'm not preaching this for the philosophy of it. I'm preaching it because it actually works for the health of the network. In Avail, we're now bringing this with AIP4. This is called as Avail Nomination Program, where we're trying to tie reputation with rewards. So the more reputation you have, the more opportunities you get, the more rewards you end up making if you perform well in those opportunities. Finally, I started off with a very big statement. I don't think it's completely dead. I think decentralization is waiting. It depends on us, on how much we want to act, how long-term we want to think about the networks, and the rebellion lives, and it lives within us. Yeah, so let's work to bring meaningful decentralization to every network, and happy to answer any questions.
Thank you, Tanisha. That's amazing. I think we should dive right in. Thanks for this presentation. I'd like to ask Franklin on stage again. Yeah, and let's kick off our TE Unplugged session. As mentioned, this session is meant to dive deeper, to discuss dedicated aspects of the concepts we've just seen in a brief presentation, and better understand how they differ and also what they share. Let's first recap. So we have 2 principles or 2 cases where we apply mechanism design. One is, in Franklin's case, CK proof markets. So basically an emerging scalability infrastructure and a layer where we use CK proofs to compress and verify computation, particularly for scaling layer 2 networks. And for pricing these proofs and matching the right prover with compute available to process the proofs, with those who need such proofs, we need a way to determine prices and to match those two parties. And Franklin's paper is about how to match them in a double auction. Proof markets is like an additional piece of infrastructure for layer 2s, typically. Now, on the other hand, in Tanisha's case, we have validators. This is proof of stake consensus. We want to make sure that we have a wide, diverse set of validators who are proposing blocks and submit approvals. Now, these cases are quite different. However, they share that we apply mechanisms designed to ensure we align incentives. And we had this term, aligning incentives, in the earlier conversations with what about autonomous agents in the systems, and how can we make sure they don't game the system in one way. So the economic approach to secure systems is to align the incentives so that any actor, any rational actor, participates without hurting the total network. This is the idea of aligning incentives. It's not paying users for doing stuff. It's like make sure that a rational actor acts in the best interest of the individual and the total network. And applying or trying to aligning incentives is the, let's say, the shared principle we can observe in both cases, in DARA, double-sided auctions, improver markets, and for the reputation score. Now, I'd like to start with looking through this security lens. And first, this question to you, Franklin. CK proof pricing has been a long-standing challenge, and it hasn't been solved, or there were several approaches. So we have the transaction fee mechanism, Tim Roughgarden, in 2020, this paper. We have EIP 1559. We have a number of papers who are proposing enhancements to EIP 1559. Then we have a different approach, Wenhao Yang et al. Mechanism designed for CK roller proof of markets, where rather focusing on the profit maximization of the matchmaker. This could also be an approach, not price finding, rather incentivizing the matchmaker. And then several networks try to establish static pricing, so better foreseeable, stable pricing for those in need for a proof. Subsidized models, we have gas-based costs of a proof, and also protocol-owned provers, Starknet Sharp, for example. So a broad variety of approaches to solve this problem, how to price CK proofs. Now, could you walk us through your double auction DARA solution and highlight some of the benefits?
Yeah, absolutely. First, I would like to preface by saying that all of these alternative models are absolutely usable, and that at this point we are more looking to optimize the value extracted for everyone involved, rather than to say this doesn't work, this is not the case, this works, it just doesn't work as well. So for instance, if we take the static pricing is easy. It's business friendly because the suits like to talk to each other, sign a big fat contract and be done with it, but it kills a lot of flexibility. Like for instance, if an operator, I don't know, through some hardware optimization or whatever, can decrease the cost, the proof cost by 20%, then the client will never see the value coming up for them until the contract is renegotiated, for instance. So this is something that is working, that is forecastable, but something that is not really flexible, and that basically kills in some ways the value that can be extracted for all of the people involved. Same thing on the other way. Let's assume, for instance, that I don't know, we have a heat dome over Europe and electricity prices are skyrocketing. Then the operators will pay 10-15% more for the electricity, and they won't be able to make back their cost or to carry it over to the clients. When you take the gas system, for instance, gas systems are very dynamic. They are very adaptable, but the problem is that they encompass such a much larger domain that is in some way correlated, but not actually the same thing as what you are doing, because stuff that is cheap on gas will actually be very expensive on the ZK system, and vice versa. And more generally speaking, the gas prices are fluctuating with the use of the whole mainnet use, right, of the whole Ethereum blockchain use. So it will be hard to match it with the fluctuation of availability of computational power, or with prices of computational power, and so on and so on. So this is actually not a bad thing to use, but it is, I mean, the concept is actually interesting, but real implementation is too decorrelated from what we are doing to actually be useful in our case. And finally, sorry, what was the third one? Come again?
Oh, there are several models. I just wonder what you just mentioned. So both tying the price to gas or have stable prices, fixed prices, is like it doesn't push proof providers or providers of proof compute to maximize efficiency and to innovate. Do you have some insights on to what extent can they become cheaper? So are we like there's a lot of efficiency gain still to make, or is it hard to, you know, optimize prices in this market already?
That's actually a very interesting question with very deep ramification. I will try to avoid going into too many technical details, not to bore the audience, but I would say that there are multiple ways of let's say that the goal is diminishing basically computational price, right? So you have multiple levers to act on that. The first one is energy price. I mean, it may sound stupid, but actually, in the end, everything is electricity, right? So if you can move your company to somewhere where electricity is cheap, mechanically you will decrease the price. That's the first thing. Then one layer above, you have hardware. Even if we are not in the glory day of CPU evolution where we had twice the power every 6 months, you still have incremental improvement in CPUs. So a proof that was costing X 1 year ago is now costing maybe 0.8 or 0.85X instead. One layer above again, you have the implementation. Proving system are programs. Unlike every program, they can most of the time can be made faster, right? Memory patterns, CPU usage, parallelization, porting from CPU to GPU, and so on and so on. So yeah. And finally, you have the highest level, which is basically operational cost, right? If you are a company and you can work with 10 guys instead of 15, then that five less to pay, and that's the same amount of money will be carried over to the effective price of your proofs. And finally, at the very, very top, it's how do you want to run your prover? Like a lot of people currently are using machines that are based on AWS or GCP cloud instances, but we found practically that these machines are really not cost efficient at all for intensive computations. On a lot, and I mean like at least 50% of the money can be made back just by switching to bare metal computers, for instance. So a lot of levers to move, and some of them are long term, some of them are short term, and some of them are middle term.
Okay, makes sense. One alternative method, I mean, with your double auction principle, you are trying to establish a completely open market for ZK proofs. The exact opposite would be protocol-owned provers. So could you elaborate a little bit? I mean, we could also say, well, this is a piece of infrastructure. Proofs should be in, you know, providing secure proofs, reliable proofs should be in the best interest of the protocol. Why not make it protocol-owned infrastructure? Obviously, you see some benefits in having a market.
Absolutely. I would say there are two main components to it. The first one is an ethical component in some way. So we like to see information flowing. We like to see decentralization. We like to see basically the community and the ecosystem taking ownership of the tools that they will be using. And the second one is maybe a bit more cynical or at least pragmatical one. And it is that companies do not have infinite manpower. We are not all running on Google or Apple budgets. So at some point, let's people do what they do best to extract the most value in the whole process for everyone involved. So if some people are out of league system administrators and can make their machine run 24/7 without any hiccup, then let them do that. Let the protocol developer focus on the protocol and mix and match between these two to generate the more value and utility for the community.
Okay, cool. We can build on this with let's contributors do what they can do best and take a look at the mechanism in the reputation score you introduced, Tanisha. So reputation models obviously are built on and measured by value contributed. And again, this is a similarity. In Dara, we have the resource requesters match with approvers based on a cost performance bidding, and the reputation score looks at the past performance of validators and then determines the score and also the access and ranking and picking validators. Now, you say influence and rewards should not be directly proportional to a validator's financial stakes. Explain why.
So it's the same principle, right? The more wealth I have, and the more I'm able to kind of get my foot in the door. And the more foot in the door I have, the more rewards I'm able to get, because often it's determined by your stake weight. And that makes the rich richer, while leaving the top, the lower rungs scraping for like the remains of it. This obviously isn't a fair system. And if we wanted to build something centralized, we already have the Web2. We have traditional infrastructure that's been built over the years. So we're just recreating history and not really solving a problem. That's why I say stakes should exist for security, in the sense that if this malicious behavior proven, double signing, slashing can take place. However, it should not exist for privilege, where because I have more stake, I get more opportunities to be a block producer, thereby allowing me to make more wealth.
Maybe it's worth taking a moment to dissect a little bit when a validator gets rewarded and how they are picked in proposing blocks, in submitting approvals.
Yes, so different systems have different designs, but fundamentally two actions are rewarded. Number one is block production. So this is where in Polygon, for example, you'd have a primary block producer. So they would select me because I had the highest stake, for instance, and they would select him as the secondary block producer because he's second in line, right? So if I don't sign, I don't produce the block, he's immediately called upon to act and produce the block. If he ends up producing the block, he gets the rewards if I get. However, let's say you're on the lower 50% and you don't have enough stake weight, right? That puts you at a disadvantage because then, because of your lower stake weight, you don't get called as a block producer, thereby not allowing you to make more economic rewards for yourself. Yeah.
And let's dive into the three components of your reputation score now. We have an attestation effectiveness, we have a proposer effectiveness, and we have a social effectiveness. Let's take a closer look. How are these calculated, or how do you compute the score based on these three aspects and dimensions?
Yeah, so very fundamentally, attestation effectiveness score is how many checkpoints you signed versus how many checkpoints you missed. So in Ethereum, they do it with inclusion delay. They see like you were supposed to include a transaction in block T, you did it in T+1. If there's a higher inclusion delay, the lesser your rewards. This is normalized over your active time because it's unfair. If I've just joined now, I've attested fewer, so it doesn't mean I should be getting a lower score. So we normalize this over your active epochs, which is how active you've been. The second one is block production. Simple. How many blocks did you produce versus how many blocks did you miss? Normalized over your active time. Also, we use something called as probability here, which means because I have a higher stake weight, I have a high probability. That should reflect in the score. right? So you also normalize it with the probability of producing blocks. And the third one is very, very modular. So at Avail, social effectiveness score, we've defined it as your cloud provider selection, the location you come from, because we want to kind of reduce single points of failure. In Polygon, social effectiveness was more focused on governance participation. So it's very modular in two ways. One, what's important to the network, and two, the weights. So I can say 70% of your score is block production, 20% is attestation, 10% is social effectiveness. So you can customize that based on how the network distributes rewards.
Yeah, and I'd like to explore the social effectiveness for a moment a little bit more, because I think this is a general observation when it comes to reputation and networks, no matter if we're discussing validators or other roles. On one hand, you have the key role or key task to complete for a certain role, which is attestations and block production in the case of validators. That's their key responsibility. Here we'd like to see innovation, efficiency gains, diversification, of course. For the social effectiveness, it looks to me a little bit different. On one hand, any ecosystem tries to have active engagement of their core contributors, no matter if we talk about validators or developers or applications on top of protocols, whatever. You'd like to have them involved in governance. And this is a new participation, is totally a new challenge to solve, which centralized organizations doesn't have to solve to the same extent. Now then, there's this attempt to say, okay, you'll receive rewards for good engagement, for positive engagement. And you mentioned a couple of criteria for positive engagement. Isn't there a risk to distract or to overburden validators with activities they should not, in fact, which are not core of their value add to protocols?
100%. There is that risk where if you poorly define, if you're active on Discord, send 100 messages, you'll get X dollars. Ridiculous. Never been a fan of that system because you can game it. However, if you have a social effectiveness parameter like speed of upgrade, where it's critical that validators upgrade their systems, otherwise the network stalls, that now plays positive reinforcement loops in social effectiveness. So it really all comes down to how critically you think about it. In Polygon, when we designed social effectiveness, the reason governance was a part of it, and when I say governance, it was specifically how many improvement proposals have you authored, not how many votes you've done, is because the system was ready. You couldn't simply author a proposal. It was hard to game. It had a very structured process. So that fell into the social effectiveness bracket. One of the suggestions, which is how many votes, that did not, because that could be gamed, and like you said, I'm not warranted to vote on everything if it doesn't affect me. So why does my reputation depend on that? So that was removed from the social effectiveness.
Yeah, this makes perfect sense. Some more words on the implementation process. So the Polygon reputation score is in fact live and applied to the live system?
So it's live only for validator admissions, which means when you're applying to as a node in Polygon, you have an admission type form that you fill. And it has a scoring logic that's open. So you can go to a dashboard, check, it's a Grafana board that's public. You could see who applied without personal information. So you see tokenized unique tokens, and you see their scores. And you as a community can say, this person got a good reputation score. Why weren't they selected into the system? Why weren't they in the node slot? Why weren't they given a slot? It created very good feedback loop from the community for us.
But rather in the sense of the community has a say, or it gives more visibility to and transparency to activities, and not so much to the rewards distribution itself, right?
Yes. So reward distribution, the reason we didn't jump is we wanted to do it progressively. So if we know it's working for admissions, and these validators are in fact performing well, we know the system works, we know the score works, right? And then once we know it, you can take more drastic steps like capital allocation, staking rewards. In fact, there is this team, which I highly recommend everyone here check. It's called as validator.info. So you can go on their website, you get all the list of validators with all their reputation scores in Polygon, which is really cool. So now, if you want to stake with a validator, you can see their scores and take an informed decision. Because you can see they're performing well, and you can stake with them more. So this is like a newer experiment that we're...
Okay, cool. Validator.info.
Validator.info.
Sounds good. Which brings us to the implementation lens. So both design draw from economic theory. So you even are drawing from Piketty's economic theory. We have Gini coefficient, who is applied to all sorts of economic networks, no matter if crypto or not. And auction theory in Franklin's case. In crypto, though, we face some particular challenges on implementation, and you touch on it, Franklin, with your diagram that you showed last. Can you again give us an overview of the particular implementation challenges you face? Because one thing is to write and verify the auction mechanism, and the other part is how to make it a reality for those who are involved, the 3 roles you mapped out in your system.
Yeah, so the main issue that we hit, of course, is the good old, how can I say that, hypothesis of the spherical core on an infinite frictionless plane, right? Theories are always developed within a given frame with hard hypotheses. And when you try to actually port them over to the real world, well, you realize that, oh, well, that this hypothesis actually doesn't hold, or oh well, we didn't think of that, or oh, some guy is trying to do some weird stuff, or oh, this stupid corner case that we thought didn't make any sense, it actually makes sense for that one guy somewhere in the middle of Wisconsin. So I would say that yes, the hardest part, of course, is to take the clean, nice research paper and actually make it into something that is resilient to the infinite human imagination, I would say.
And where are you in this journey?
Should I really reveal that, or am I at risk of being sniped by some people trying to pen test our system? I would say we are close to the end, but in some way it's it's really an open-ended problem, right? Whenever you, I would say we have something working right now, but whenever you see some kind of undesired behavior emerging, then you have to squash it one way or the other.
I wonder, I mean, Tanisha, you introduced how you implement step by step these algorithms at Polygon. Are we ever at a stage where it's final and where we can say, okay, we can make sure that we have found all the vulnerabilities? There is no way to game a system anymore. Franklin, what do you think?
Oh no, I'm saying I'm an engineer. I have seen so many unexpected stuff that I'm always starting from the hypothesis that software is never finished. I mean, at some point you just have to embrace the chaos, and it helps me sleep at night.
And do you see any difference? Because many people, if I talk about economic security, say, well, we have software audits. What's the problem? We have security audits. But economic attacks are slightly different. So how do you approach this to get to this stage where we say, okay, we can never fully guarantee this is like an open-ended exploration on how to secure such mechanisms? What are your criteria to get to a stage to say, okay, it's ready for launch?
When the deadline is coming in? No, more seriously, we are, I would say, at some point you have to accept that there will be atoms, there will be, I wouldn't even say necessarily attack, but unexpected stuff happening, bug being revealed or whatever. So I would say we're kind of working like a counterintelligence service. You know that there will be spies in any case, so what you are really trying to do is not necessarily to prevent them from coming in, because it's completely impossible. But what you are doing is you are just taking the problem one step further, and you are setting up monitoring, you are setting up inspectability of the system, you are setting up all that kind of, let's say, facilities that are helping you to not block everything, but be able to immediately detect when something goes wrong. define what is going wrong and have some contingency plan to actually address the stuff going wrong.
And again, this is about aligning incentives. It's more make sure that everybody is really incentivized to do the right thing, because the idea is we have open systems, so it's not about blacklisting or granting access rights. Like, as long as you play according to the rules, participate. And this makes what this economic security a special, let's say, component, special aspect of crypto security. Tanisha, you also gave us an overview how you step by step implement and roll out the reputation score. The first component you need is data. So what data do you use for defining a reputation score?
So it's a multi-fold process. The first data is just surveying validators. This is me getting a lay of the land, right? This is where we ask them, do you think how many years of experience you have? And then checking whether there's a correlation between experience and performance. So does that mean that validators with higher experience tend to have a better performance? So this was the first study. The second was a company study, which is what is the vision of the company? What are their goals? So this is where the social effectiveness is modular, right? For some companies, it's diversity of validators prioritized over governance. So the lay of the land is that. And then the third one is for the reputation score itself. These are fairly like on-chain. So even when I say governance, I'm not speaking about temperature checks that we do on forum. It's the actual on-chain vote that they cast. All of these are fairly on-chain and traceable. It's just that once you know where to pull them from, you can pull them, apply the formula, check the epochs that they've been active on, and show. So validator.info has already kind of done that. They've taken that on-chain data, applied the formula, and kind of put it out on their website.
Okay, that's cool. That sounds comparably easy to other reputation mechanisms. Cool. Then next step is the algorithm itself. So how to compute the exact score. You said it's not implemented yet, or is it available for other protocols?
No, it's not implemented in other protocols. And I think the biggest challenge in implementation is not so much data, it's actually the mindset. How do you convince protocols to invest in this? Because your reputation needs to sit on an identity, something that I can take and show you and say, look, this is my reputation, in a way that's secure. Do protocols want to invest in this? Is it easier for them to run their own foundation nodes and keep the system secure? Or do they even want to invite external node operators? I think that's the bigger challenge today.
Which brings us to robustness and manipulation. Again, there are attack vectors. So you said, for example, simplest attack vectors, if you vote, you can increase your reputation score. That would be comparably easy. Are there other aspects maybe to highlight where it's particularly hard, or where you worked hard to make it hard to game the score?
So whenever we design like reputation, we make it a point to check for attack vectors. This is how we eliminate. We make a list of everything we want, and then we start eliminating, which is we cannot have GitHub contribution, for example, PRs, because that can be gamed, right? That's how we kind of down select our ideas. There are always attack vectors, but that doesn't mean you can't go back to changing it. So given that you have a good governance system, you can go back and propose that, I want to add this to social effectiveness. I want to remove this. And then you back it up, and then the community arrives at consensus, and you can change. If there's an emergency, you have an emergency governance track that allows you to change sooner. So there are always attack vectors, but given that this is less subjective, we're already eliminating a lot. All of this is purely performance on-chain metrics. It's as objective as they can be.
I was just about to say the attestation and block production side is probably pretty much reading activities, right?
Yeah, exactly. And then when you tie incentive and capital allocation to it, it becomes a self-regulating system. Because now higher reputation, you're more incentivized to perform for the health of the network. The more you do, the more incentivized you get, rather than the more stake that's just sitting there.
And the final step for optimizing such algorithms is always evaluation. So there are networks who in fact ran A/B testing on reputation. So for example, definition of reputation based on expert assessment versus algorithmic assessment. Is this something a direction you explore?
I have read a lot of research papers on subjective interpretation of praise, transforming it into scores versus this. Personally, I am more of an objective person. This is a personal choice. I tend to like params that are fairly straightforward, which is why I designed this, but I have read of papers where even subjective praise has been transformed into scores and kind of been looped back into the system. I just don't think we're there yet. And I don't think validators need that. They're very clear deliverables to do to secure the network. And sticking to that kind of objectivity just helps with this use case. If I was designing reputation for gamers, my approach would be completely different.
Makes perfect sense. All right. I stop for a moment. Do you guys have any questions or comments or insights on what you've heard so far? Get a mic.
Thank you for... Oh yeah, there we are. Thank you for both very interesting talks. My question is for Tanisha. My name's Ellie, by the way. So when it comes to the objective measures, and so my expertise is more in the Ethereum validator ecosystem for the mainnet, which you haven't really discussed. But and Cosmos, which is completely different. But in this case, the objective measures are performed through the code, and there is a process by which the clients, the validators, are kind of in a process of interrelated observation of each other's behaviours around attestations and rewards. For people who have attempted to run a home validator, solo stakers, the things that you're saying would increase reputation, such as, whether you've successfully produced a block. They're limited by factors such as your internet connection, not by your stake. They're limited by actual things in the world, whether you're moving house and need to move your machine. So you're suggesting, actually, in this case, that those with more capital who can run them in the cloud via Amazon, in data centers or in, on their own servers with massive capital would actually benefit from reputation, from what I'm hearing. When the kinds of things that we need to be rewarding and incentivizing, if you break down the actual roles that validators do, which I think, people like Barnaby, from what I have listened to and read of his work, are trying to do, what are the actual roles in a granular way that we should be rewarding, and which actors are performing those roles, and how do we actually reward security of the network, which in this case is rewarding probably home validators much better than we are now. And then we have factors like liquid staking, which there's more incentive to be a liquid staker now than to actually be a home validator in terms of the rewards that you're going to receive. So for me, it needs to happen through the protocol itself, but the protocol itself needs to be adapted fundamentally to identify which contributions to the network are important. And I'm not sure your ranking system is doing that. That's why I'm curious of your response.
So just to rephrase and understand your question better, are you saying that we need to get the protocols to adapt this right within their systems of how they allocate rewards, or?
Yes.
Yeah.
Yeah. So, it is already a reputation system, is what I'm saying. The code itself is, in Ethereum's case, the protocol is a reputation system. It's rewarding and penalizing based on the validator machine's behavior according to rules which are set by the client. So, and agreed to through various governance processes. So that is the thing that needs fixing.
I agree, but like I don't think Ethereum looks into social effectiveness score, does it? Like it looks at block production, it looks at checkpoints, but it doesn't have more granularity into skin in the game parameters for what the validator, the speed of upgrades, the governance participation, their skin in the game. Is that granularity existing in Ethereum?
So, I mean, it's not necessarily able, I mean, we know, for instance, what the proportion of nodes are and validators are being run by large companies, for instance. In many cases, so they're not participating directly in governance unless they're sitting on dev calls, presumably. Different with other blockchains, I agree. I mean, we can have this conversation later, but the point is the social and technical dimensions are interrelated to the extent that we should be able to deal with this through the protocol design. And I don't think you can say that, just because this large company has a large proportion of the stake, that they're not going to be good at governance. I mean, my experience with Cosmos validators is in fact that they care a lot more about the longevity of the networks than delegates, people who are delegating to them, or people who are voting independently often. So I think that, that it's much more complicated than that. And if they're performing their functions well, that's good. Security, however, is the core issue around someone like Coinbase running a vast majority of validators for a network, right? And often they won't participate because they understand that conflict of interest in the Cosmos chain's examples. So there's also, so I think you can, in blockchains with, anyway, we can talk about this later.
Yeah, so I'm
dominating.
No worries. It's just, it's good that you're kind of saying that. To answer your first part, that is the biggest challenge. Protocols, that's exactly what I was speaking about, which is protocols embedding this reputation score into their systems. The second part about what you said, it's not meant to replace the bigger ones. It's meant, reputation scores, to give accessibility and visibility to the ones who are performing well and also have skin in the game, versus someone who's with a high stake but not having skin in the game. Not upgrading fast, not participating in important decisions, client upgrades. That's the difference. It's not meant to replace the bigger ones all of a sudden with the ones below. It's meant to create that accessibility where they can move from one quantine to other, provided they're performing on all three fronts well. That's the goal, to create that accessibility pathway, which doesn't exist today. But yes, we can definitely chat more.
And I think you were referring to Ethereum rainbow staking, which is also a new approach on how can we diversify the landscape of validators. And in this case, it's about having a more granular menu of services this validators can choose to participate and contribute to, so that we are not like they compete for very particular services where they are best. And this brings us back to Franklin, where are you best, and how to maximize also the efficiency gains and security gains in our case. All right, I'd like to close this round with a tiny thought experiment. Let's cross-apply each other's approaches. So I'd like to ask you, Franklin, would it make sense to add a reputation layer to define CK-proof pricing?
I definitely think so. When you take a look at the existing real-world, real-life auction market, none of them are completely open, right? It can be the bulky guy at the farmer auction, it can be your Swiss passport at Sotheby's, or it can be the SEC at Wall Street. But in any case, you always have some kind of more or less explicit barrier to entry. And this is an issue that we hit as well, because when we are thinking of things that can incapacitate or damage a network, we are always thinking about some vicious, hyper-smart hackers from wherever in the world. But the most issues that we have were actually coming from what I would call involuntary attacks. So it can be people running the software wrong. It can be people mishandling their network stack. It can be people not updating stuff. I mean, a lot of issues are actually coming from non-problem, non-hostile actions. And I think that I'm actually completely convinced that a reputation measure, reputation-based barrier to entry, that shouldn't be like hermetic and be once for all, right? It's more like go, get out, sort your shit, get your ducks in a row, and then come back, right? And I definitely think that this is the next step for our own system. Because on the one hand, we don't want to lose time and to lose money giving proof to people that cannot actually handle them. But on the other hand, we still want to give chances to these people that are just clumsy or not really hostile. And we need to give them a way to re-up their reputation with us so that they can re-enter the system for the greater benefit of everyone involved. So yeah, I'm pretty sure I'm absolutely deeply convinced there is a lot of synergies between the two.
Right, and Tanisha, would it make sense to implement a market design for validators?
You mean the bidding market design?
Bidding market, yeah.
I mean, if you look closely, it is that. Either through your capital or through your stake or through your delegated stake, you are technically bidding for a slot. So in a way, we're already at that system.
So you're increasing skin in the game, in a sense.
Yeah, but it's also a problem in that sense that now the wealth, what about the economic angle of it? It's secure, sure, you're putting in skin in the game, but what about the rich being richer and continuing to dominate the network? How can you have both skin in the game and the economic accessibility to rewards? So that's the real challenge.
So not sure if it's a good idea to combine.
It is a good idea to combine. Like, stake should exist. Like, reputation is never meant to replace stake. A minimum accessible stake should exist for slashing, for corrective behavior, for security. But reputation should exist for fair opportunities. And what that reputation is for different networks will vastly depend on their mechanism design.
Any final comments from the audience? Okay, let's wrap it up. Thank you. Oops. Do we have? Yeah, we still have time, no problem.
Thanks. So I had a question for Tanisha, also on sort of robustness and security. How do you think about Sybil attacks? Like, ultimately, if your goal is to, have less giant operators and, have like more little guys in the game, how do you worry about like giant operators pretending to be a bunch of little guys, and like, how do you defend against that?
That's a great question. So in my earlier talks, I'd always spoken about reputation sitting on an identity system, a ZK identity system. I didn't speak about this time because it was focused more on this, but every time I think of reputation, I think of it sitting on an identity, and we did this with Privado ID at Polygon. So you have a basic identity system. Whatever your admission score is would sit on that. You do KYC, of course, to get that, and then you could use that to enter the system as a ticket, as a very valid ticket. That's how we've been thinking about Sybil resistance.
Okay, thanks.
All right, any more questions? Good. Oh, yes.
Hi. So I have a question about reputation. I want to bring a different angle. I'm more in the DAO management kind of thing. I believe that sometimes when we talk about coordination and we focus only in technology, we forget that there is a lot of complexity in the human side of reputation. I think there is like a need to complement some of the consensus layer kind of objective reputation with more soft. I think you mentioned a little bit about how can we translate more soft, like perspective data into more objective, rigorous kind of measurement? Could you talk? And I mean, for whomever, but like a little bit about that.
So just to again understand your question right, are you speaking about in a DAO situation where there are DAO members, how could you potentially translate soft consensus into like tangible reputation scores? Is that?
Yes, I think that's mainly it.
That's a very tricky question. So I've worked initially when I was new in the space. I used to work for this company called as DAOLens. What we used to do is we used to do onboarding. So you'd join a Discord, you'd go through a really nice onboarding flow, say, what's your purpose? Why are you here? And then based on that, we would give you like a tag on Discord. And that would become reputation. That's literally the simplistic way we started. Turns out it's gameable and everybody gamed it. So we had like grants tied to it, we had community incentives tied to it. Terrible idea. Learned it the hard way. I don't have an answer to your question. I need to understand more about your DAO and the objectives to be able to say, how can we tie soft consensus into like hard reputation that's not gameable? It really depends. My favorite way to do that often is vote escrows. It's not soft, it's definitely like a escrow contract, you lock your tokens in. And based on how long you lock, how much skin in the game you show, you get a multiplier. I tend to love game theories like that. Because one, it's healthy for the tokenomics, and two, it's also skin in the game. Like the longer you lock, and it's also not necessarily wealth-based, because he can have a lot more wealth, lock it for 1 year, I might have lesser, lock it for 4 years, I get a multiplier that might make me equal to his voting power, or maybe even more. So I'm more into those kind of ways to see how do I bring in some game theory angles with vote escrows in DAO systems, especially if you have a token or an NFT.
Okay, great. Thanks so much, everyone, for this free sessions and the TE Unplugged discussion. I think we are ready for lunch. We'll see you again at 2, where we continue with another 2 talks and a TE Unplugged session. So happy to have you back, and thanks for now. See you at 2 p.m. All right, let's kick it off. Let's kick off the afternoon. Let me briefly, before we jump in, give an overview. Now we are back with 2 talks. First one is Philip Zahn, 20 Squares, about tokenizing short-term debt, building on-chain infrastructure for invoice factoring. And the second one will be Vasily Sumanov, Valueverse, introducing his token classification framework and AI-powered utility analytics. And you might ask, how are these 2 related? You'll find out in the TE Unplugged session that we'll run right after. So it's 20 minutes talk, another 20 minutes talk, and then the speakers and the session lead come on stage, and we do like connecting the dots, providing context, peer review, asking critical questions. So make sure, stick around. And session host of this TE Unplugged is Mark Richardson, Carbon DeFi. So thanks for being here today, and the stage is yours, Philip. Give them a round of applause.
Thank you very much. All right, so this talk is about the project we as 20 Squares have done for a client that asked us to implement a design, a market design, a pipeline from tokenizing off-chain debt into the blockchain, implement markets, primary markets, secondary markets, and then also think about the settling mechanism back and how it touches again into the fiat world. The starting point for this project was actually a narrow use case, and I should also say this is work in progress. It was initially started by Inverter that brought us onto the project. The context was a factoring use case in a specific scenario. The stuff I'm talking about will be written out up in a white paper and also open sourced in a couple of weeks. The factoring use case was embedded into an institutional structure where the government already has a digital invoicing system in place, and the task was in principle to build on top of that. While working on the factoring, we realized relatively early that the components we need to define, which are obviously driven by lots of constraints that I will talk about also in a minute, are in some sense more flexible. And at that point we started out saying, okay, let's try to think about this in terms of a stack of modules that can be reused in different contexts. The talk will focus on 2 things. I will talk a bit about the design principles that we want to apply, and also on the discussion of the stack and also the components. Now, I have 20 minutes or 18 minutes, something now. It will be short and high level. Before going into our design, let's talk about very briefly about the context. This is a slide, and the topic itself is obviously quite common. Many people talk about this. Many people think about these issues. So why would you be interested in tokenizing debt? There are many reasons. One of them is obviously that if you have a debt contract between party A and party B, which is typically a private contract, it's highly illiquid, very often opaque, which is very hard from pricing perspective, and obviously also high friction because there are lots of legal and regulatory constraints. And the legal and regulatory constraints are specifically relevant if you want to go beyond a bilateral pair between A and B, let's say seller and vendor in terms of if the factoring case. But B basically holds the receivable and wants to sell it off or wants to liquefied. At that moment, party C enters in, and that typically creates a lot of legal frictions and regulatory frictions as well. Also for C, if C again wants to kind of sell on or restructure the debt. Now, thinking about the blockchain system or tokens in general is pretty evident and quite obvious. Many people have thought about this application or other applications as well. So what we are talking about obviously has many other teams and projects working on from different angles. Now, 3 obvious things: you can standardize the debt instrument, you make it audible, you can also track information over time. Information is key, specifically if you want to price things. That again, keeping track of information is relevant if you want to go between or beyond the relationship between A and B, but let's say C and then maybe also D, E, etc. And lastly, you might have composable claims, which is very nice because you can very effectively and efficiently form portfolios. Okay, what's the outcome? Very simple. We are creating a market that is hopefully more efficient so that it serves both sides. Those who are seeking for capital get it at cheaper price, and those who want to invest basically have new opportunities and new yield. All right, what are the core principles? Key thing, not surprising in the blockchain world, is modularity. We want the pipeline that I basically will introduce has several components, several stages. They should be reusable or repluggable as well, that if you need to make a change, you're not affecting the whole stack, and you can do easy upgrades, very straightforward. Another key thing is risk. That's the bread and butter of a debt relation. Party B, which basically is under risk that A can't pay back, always needs to be in a position to understand what is this risk, and possibly also how to price it. And that obviously is not only true in a bilateral relationship. Again, if you think about a supply chain situation where a supplier and the buyer basically are in a long-term relationship, clearly understanding the risk is relatively easy at some level. But again, if you're breaking that and want to go beyond the bilateral existing relationship, then things are more complicated. Information tightly linked to risk. Clearly, again, in the supply chain scenario and factoring scenario, if I'm the supplier, I have a lot of information about the party with I'm interacting. But again, if I'm selling on along the chain and want to sell the debt basically further along the line, then clearly information might get lost. That is obviously true if you're outside in the off-chain world. And on-chain, there is a question of how can we keep information around so that everyone basically has the information to, as best as possible, price the instruments. Tying it also to risk, clearly information is tightly linked to that. And also the question in the system of the design, from a principal perspective, the question is who is actually carrying the risk, which you have to think about a default. And if you're selling on, who is actually from a financial and economic perspective affected, and what are the incentives behind it. Now clearly, this is a whole, that thing itself, how to keep information around, how to keep track of it. You can have a very long discussion and basically its own dedicated session on this. The thing is obviously what we're trying to do at the moment is to compromise where you have some on-chain proofs, you have an off-chain component that basically stores information, let's say information about balances, etc., that are not yet in an effective way be able to put on-chain. At the same time, the reality is you also need to think about privacy. It's important, but also it's legal and regulatory requirement. And then lastly, if you want to build a marketplace, incentives are key. This only works if capital as well as those who are seeking capital have an interest actually using this market. And obviously also for other parties involved in the system, we have to think very hard what are the incentives. And also how does it link to information and risk? Yeah, I mean, this is pretty standard. There's no surprise there. We need to align all the players in that platform to basically provide liquidity and also use it effectively without wrecking the design. What are we doing? We have, at the moment, we have 6 components that are basically, you can think about it as a pipeline. You start on one end, which is the digitalization step, and then basically at the end there is the settlement default handling. In principle, there's a 7th step basically linking things together, but that's pretty straightforward at some level. Okay, I will go through these components. What is important to understand is that they are the outcome of thinking about specific and several use cases. For parts or specific applications, you might not need all of these elements in the stack. For instance, I have one which is called risk assessment. This is basically providing the possibility for external services to inject risk assessments. This is not something that is necessarily needed in all cases. Same, you might have cases, maybe because of legal reasons, that you can't have a secondary market easily. So that might also be a component that is not available or not relevant. And lastly, what is important to understand, if you think about this as the pipeline going from off-chain into handling and then back, if you make design choices along the line, for instance, if you decide on the primary sale, let's say you have an auction, clearly there are dependencies between the components that come later. Okay, what's the first step? The first step basically is pretty straightforward. It's the idea that you have some kind of relationship in the off-chain world between party A and party B. You need to make sure that whatever is the underlying thing that you want to tokenize actually is unique and real, can't be tampered with, can't be manipulated with. How you do this, there are various options for this. In the case of the factoring application that we have been looking into, as I alluded to before, that problem is basically solved by a government structure that is enforcing invoices to be sent into a system for the reason of tracking taxes. So in this case, we can basically leaning on that specific infrastructure. But obviously, if you don't like that and you're looking into another market where these kind of interventions are not happening by governments. There are also many private ways of doing this. The tokenized step then basically is the first step. Once you are in the digital realm, you can, there's the putting it on the chain step. What we are doing at the moment is, and again, think about this as abstraction barriers. Once you're looking in a specific scenario, let's say factoring, but you can also think about funding projects. Let's say you have a construction yard, someone needs or has a very lucrative contract but needs short-term liquidity in order to fund or buy equipment or material for it. At that moment, you might be looking into a very specific, unique element. In the case of factoring, if I'm looking on the universe of companies and I get a lot of invoices from these specific companies, they might be relatively similar. Now, ex ante, to make that system flexible enough, we don't know what exactly will be the right or the best assumption. So the thing that we do with this module is essentially introducing a step so that as an abstraction barrier, we assume a very conservative stance, namely each title that gets tokenized is basically unique. Yeah? Which again, if you think about factoring, A and B, let's say 2 invoices consecutively happening over the years, it's quite likely that the 2 different invoices and receivables in the back will have the same risk. Yeah. So again, as a starting point, we assume each title that we are tokenizing is different, is idiosyncratic. And now you can think about what are the natural next steps is, how can we make these things at least partially more functional? That's basically the rest. And also these different modules serve exactly that purpose of providing different setups and cases for when this system or when the different titles are actually easily tradable or when they are not, when they are really different. Okay, one scenario is the following. We talked about before, you need some risk assessment. This could happen on the individual party that is actually buying things in the market. But in the case of factoring, this might be not very effective in the sense that there might be a large universe of companies that you need to basically monitor. So how do you do this? One option that we introduce is basically an extra module. It's a risk assessment module. The idea is you have an on-chain registry of accredited raters. What do? They can basically attach scores to the NFT before, and the idea is that this score might then be used as a classification schema for the primary market that comes next. Yeah. So you might have 4 categories, and you're looking at a universe of receivables in the factoring case that are very much the same. And then you basically have different ways of allocating them or selling them to the outside world compared to if I'm really looking at, let's say, individual project-based tokens that are very idiosyncratic. Maybe as a side note a bit, the idea of rating agencies or basically partners, entities that do this has a mixed bag history in the past, let's say 20 years. We had specific problems with some of these companies in the past, let's say it like that. So here's an additional thing where if you are tracking this information in a much more public and transparent way, clearly there's also room for, down the road, introducing a reward and penalties in principle for the behavior and for the accuracy of these ratings. There are problems to be figured out, etc., but at least as a possibility, this is another route that is not available outside. Okay, primary markets. So what are we talking about? Starting again from the assumption that we have unique NFTs representing specific titles. By the way, these titles are relatively simple. We're talking about short-term debt, which means there's a maturity, there's an amount, the parties involved, and then possibly also off-chain data that is relevant. Now, depending on the kind of tokens and the underlyings you're looking at, you need flexibility in how you allocate them. So let me give one example. If you have, let's say, the project-based construction yard example, maybe €1 million in total, to allocate this and similar to project tokens, it might actually sense to really just sell them individually. You could use an auction for selling them on an individual basis, and that would be it. A next step towards making things a bit more fungible would be that if we have NFTs that have similar risk structures and have been asserted like this, then we can basically do batch auctions on them. So you bundle the risk by tranche, basically, and then you do this step by step and basically sell the whole bundle at once. And lastly, I'm going a bit more in another direction if you want to go more into a DeFi scenario or setup or market design. There's something very simple you can do. Well, you basically build some kind of monetary market fund equivalent that buys NFTs at a specific price that you can algorithmically set. You can also govern it if you want it. And then in that case, the NFTs go into the pool. Basically, when they mature, their rewards go into the market, go into the pool, and they are basically buying up again the next tranche of NFTs. Now, if you do this, then you can have a participation from an investor side in the pool. You're basically holding an equity share equivalent in that pool. And ideally, if the thing is well designed and works well and the economic conditions are right, that thing will create value over time. There are also other considerations in this case, clearly, that are important to allude to. In the pool case, you are sharing risk across different parties. So you also have to think about moral hazard, essentially. Is there actually one who's monitoring it? And then, which is also relevant, there's the question of what happens in default. All of that will have different consequences. In the case of the pool, you in principle can enable a structure where the pool itself has ways of going after defaulting entities and basically try to get the proceeds in. Okay, and then lastly, liquidity and settlement. So in some cases, you might actually be interested in a secondary market so that after you have done the initial sell-off, which typically involves the scenario, again, of A, owning to B trying to sell it off, getting liquidity, and then what happens if C buys it? Maybe this stays with C, but there are good reasons why if a market has a secondary market that C can basically sell it off again, that this might overall increase liquidity and also make the market more efficient. Now, I mentioned before the pipeline we are building is contingent, so if you are making choices on the primary market, clearly that will have an effect on what you can do and what is in reach on the secondary market. So again, if you're thinking about an auction, then clearly you have to think about some kind of OTC design afterwards, which might be complicated, which might also not be liquid enough, and have other also regulatory hurdles on top. In the pool path, just to contrast it, there you are basically looking at a participation token, and that token might be tradable on your preferred exchange. So again, and not to kind of to oversell it, but or not kind of to make the OTC case too bad. Clearly also in the pool, there are many, many legal questions. Yeah, I'll come to that in a minute. And then lastly, the settlement obviously happens, so you have to have a pipeline for getting the fiat stable swap basically done at the beginning and also at the end. The assumption is that partners seeking liquidity will not be active on-chain themselves, so you need to have a lot of integration, which boils down to many mundane things like ERP integration and other parts that you have to have in place in order for this to work. Now in this case, in the factoring case that I alluded to before, a large chunk of this is already done because invoicing, etc., is already digitalized and is enforced by a government platform. Yes, and then lastly, you have also this question, if someone is defaulting or payments are late, clearly this is behavior and information also that you can feed back into the platform. Now, it's not totally evident how you want to do this. You might want to say that the platform is basically agnostic. It's the task of those who price risk to include this. You make this information maybe public, but that's it. But clearly, you might actually also more actively design the reputation system and the consequences of that. Okay, so very briefly again, summary, we have an oracle phase, then we have the NFT basically as a base assumption on what is the risk involved behind a specific title. We have a phase where a possible external risk assessment happens. We have the markets, primary and possibly optionally secondary, and then also the settlement part. So again, reminder, what is the idea? The idea really is to have a modular components in place for the different scenarios. So the factoring case is one, but SME liquidity is a big concern in many countries, Europe in particular, where you have profitable businesses that don't have access enough to short-term liquidity, even if profitable. And in some sense, the idea of building such a pipeline, or is at least making a partial contribution towards improving that scenario, this situation. All right, let me end on the following. All I said before about what we designed and what we kind of did in a collaboration is actually straightforward and pretty simple. It's not complicated in the end if you do it. There are options, there are trade-offs, but you have to go through the trade-offs. The actual kicker is obviously the legal part. This is the actual challenge. depending on where you are, depending on with whom you trade, whether it's going cross countries, a lot of complications arise. You might have wondered at the beginning, why do we have these 6 stages? It's not because we feel like 6 stages make a lot of sense purely from a market design perspective, but we need sometimes barriers in order to be clear and steer clear of what are the consequences of moving from one level to the next, so that it can be legally figured out, it can be put into a frame, and you might also make a decision on what is the market structure purely on legal and regulatory information. Just to give you a flavor, and again, many of you will know about this, if you think about a debt contract, which is a private contract between party A and party B, you can't just sell it off to party C. You need consent. That consent actually extends into the question of what can you digitalize? How can C then again sell to D? So you need also secondary consents on all levels. What is the legal status of the pool that I mentioned before? Don't ask me, ask a lawyer. It very much depends on where you are. And then again, that's the key message basically so far. The legal friction remains the key thing that disturbs all of this wonderful, nice, abstract thing of compositionality along the pipeline. Okay, I don't want to end on this in this bad way. So we have been working on this. Let me very, very briefly say something on this. We have been banging our head against it, and we think we have a possible path forward that we are working on now, and stay tuned to hear something about this, hopefully also in the near future. Very quickly, there is a very old-fashioned instruments based on negotiable instruments that could be used. Some countries are updating them on a new legal level, and that might be actually, at least is our belief and the belief of lawyers we work with, a possible entry point in achieving some form of composability that you're not needing consent on all levels. And you make things, hopefully, that's the goal, tradable, aggregated. You can disaggregate if you want. And hopefully less, and maybe even no structural legal regulatory changes when traded. Again, think about party C, having several receivables. At that moment, they are refunding it. They're typically doing some securitization. They might be running a bank. They might have other financial instruments behind it. All very complicated and obviously a transition from the original relationship. Thank you very much.
Thank you. We stop here and continue with the second talk, Vasily Zumanov, Valueverse, but Philip will stay with us for the TE Unplugged session where we dig deeper into his model and look through the lens of Valueverse token evaluation tool.
Okay, yeah. Hello, everyone. Nice to meet you all. So, and today I want to focus on token classification, but built on scale. So, my main question was how to scale token analysis to millions of tokens in the future, right? So, this was my main topic, and I will try to focus on on how to do it. So, at this moment, if you want to analyze any kind of asset, for example, digital asset, we have mainly 3 parts of analysis, right? We have fundamental analysis, focusing on supply side and demand side. So on supply side, we track token distribution, who owns, what amount of tokens, who accumulated, who bought, who sold, anything which is related to token movements in the system. So this is supply side, and also liquidity analysis is a part of it. The second piece of fundamental analysis is demand side, which is always overlooked, as I think. So it's mainly intrinsic value of token, how it captures value, and what is going on inside the economic model of the token. And the third one is speculative or sentiment analysis. So we analyze crowd attention, Twitter, everything. So, and combining these 3 pieces, I think it's possible to build more sophisticated view on tokens, on analysis, on investments and trading, and all this kind of things. So. If you will see the fundamental part of the analysis, we see the token market metrics, and we see what I call utility-centric non-market metrics. So for token market metrics, we see token distribution, as before, markets, liquidity, who owns what, and who bought, sold, and how it happened. And for non-market metrics, we have token utility, economic functions, how token captures this value, what are the particular pathways for value capturing, and particular metrics of this value capturing. And why this token value analysis is missing, at least on scale. Of course, we have some reports, we have some bright minds that try to deliver some reports and don't change data on June, but on the scale, it's still missing. There are several main problems. First is that all the tokens, they don't have a standard design. I'm not talking about the ERC20 implementations, but even then. There we saw a lot of different composability and variations. I'm talking about economic functions and how token particularly works and what value it captures. We have mixed utilities in tokens. It's not like the IPO when there is a lot of documentation how this share exactly works, what are the rights of every type of this share. In the tokens we have code, we have some GitHub, Gitbook, but there is no standards for reporting. And now Blockworks, for example, they try to initiate such kind of standards to report the token design and at least token distribution metrics. So and we have a lot of tokens, we have a lot of data, and there were no tools to make this value analysis scalable before. And I tried to build one, and this is what I want to show today, how it works and what is the idea behind. So some kind of a background. So I had designed a framework for classifying token utility and value capturing. So here we have some pieces of it just to showcase. So it was a peer-reviewed research. It also was awarded by Tokenizing prize last year. So thanks for the community to vote for me. I was very happy to get this award. It was really a very big milestone for me, and it was one of the first steps why I decided to move forward with this idea, because this community support was really a lot for me. So here you can see, for example, the optimism token decomposed to governance and conditional action. It's quite simple token because it doesn't have any cash flow at this moment, so you can vote, and if you vote, you get some governance value, and that's it. It's very simple. Also, you have a BNB as a different, option to see that it has a lot of origins of value. It has a lot of economic mechanisms in one token because it provides you access to launch, but it also has a part of consensus for Binance Smart Chain. You also can have a discounts on exchange. You also can pay for gas to purchase the block space, and yeah, so it's much more complicated. So and to analyze thousands of digital assets, what we need to do for each of them. It's applied similarly to every token, right? We need to analyze origins of value to understand these elementary economic patterns and pathways for token to acquire value. We need to understand the value capture mechanisms, how these origins of value are connected, how they influence each other, how this works as a big and complicated system. And of course, we need to understand implementation patterns, so how this exactly works in code, where the cash flow comes from, how token is taken, for example. So. And of course the metrics, because without metrics, all of this is almost useless, right? So, and here is some, case study or some small examples. So we have a velodrome. A velodrome is quite known token over DEX on Optimism, and I think that probably some of you know what velodrome is and how it works. But to be short, you stake token into the voters crowd economics, which was pioneered by Curve a long time ago. If you stake your token, you're getting one future cash flow. It's a rebase that just offsetting the inflation of the token. Also, you get a conditional action, so you can vote. And if you vote, you get a governance value, and simultaneously, you're getting the protocol fees. So if you never vote, unlike a lot of other protocols, you will never get a protocol fees, in particularly this case. So we see with these arrows, and it's basically a graph, how these origins of value influence each other, how they really work, and what is the condition, for example, to get fees. And after that, we understand all the contracts and understand what to calculate. So, and this is an example where we come from unstructured documentation to comprehensive understanding of a token with all the metrics and stuff. Because the metrics are follow. So we see, for example, bribes, we see fees, we see rebases also, and we see APRs for 1K of vote escrow valid tokens. And I want to also add here that these bribes are also reflecting the governance value. So we're not only checking the cash flows, we're checking the governance, because the governance is, in this particular case, has a cash flow metrics because it has some monetization approach through bribe market. So, and after this, so when we decompose the token to the particular system with understanding how it works and with metrics, we can say that we know something about this token, as I think. So, but how to analyze all the tokens on the market? So we analyzed one, and probably you will spend several days to analyze this token, to read all the contracts, understand how it works, to find all the relevant metrics, to build them on Dune. So we need to do the same. We need to find origins of value. We need to identify them. We need to identify all the value capturing mechanisms and implementation patterns. And this is a foundation for some metrics building. So when we faced this problem first time, we did everything manually, and of course, we spent a lot of time. It was really painful because documentation is not perfect. You need to dig into it yourself, ask the team, and it's not easy. But we understood, of course, that the only way to scale this is to do AI. So we've used a line graph approach. We have several agents in a row. So as an input source, we at this moment using CoinGecko API. It's used just to get trusted information sources, so GitHub, Gitbook, website, and everything, just to understand where to take the information from, because if you will use the whole internet to get information, you will be lost. There are a lot of irrelevant blog posts, probably some tweets that are not correct in terms of token design. So after that, we have a research node that explores, extracts valuable information, builds a graph of all these functions, makes some formulas around it, so finds all the dependencies, makes some summary, and assemble this into the database record, which is at the same time like token page of the website. But of course, we understand that all these websites and UI, as it was correctly said by a guy from Outlier Ventures, is some legacy thing. We more presented to show how what is inside, because I think this type of thing will be used by other agents that just need to understand how tokens work. Tokens were asked by some owners of this agent. But what is the main value of this process? So before we apply this process, we have just fragmented information. It's some unstructured information, GitHub, Gitbook, website, maybe white papers. But after that, we have a database record, which is clean, which is standardized. We understand, okay, this is this source of cash flow, this is that source of cash flow. So we have a digital twin of a digital asset in our database, and we can work with this structured data sample. So for example, this is a Hyperliquid. Hyperliquid is a well-known project, is quite on hype, and why it attracted so attention, besides the fact that found bought a lot of tokens, initially no VCs, kind of a fair launch. Also because it has a very strong fundamental metrics, a lot of cash flows, they make some buybacks, they have some discounts. It's a kind of like trading layer one, so they have a lot of different, but if you will see these 5 human readable token functions or origins of value groups, because each token function that we understand that as humans is a group of origins of value, each of them is a cash flow. All the 5. Stake-based discount, you get cash flow in the amount of what you saved when you didn't pay for the service the full price. When you have a referral fee sharing, it means that somebody, you invited someone and you get a share of what a service generated money on this customer. Stake delegation, you earn from layer 1. Consensus, you earn from layer 1 from some fees. As a deflationary native, it's an indirect cash flow like YIP 1559, something like this, right? So the supply decreases and you're getting an indirect cash flow. So we see the token that has 5 sources of cash flow, finally. And all of this was done by AI. So we just plugged CoinGecko, we got this, and it worked. And this was one of the biggest success that I saw when we finally delivered it. Sorry, I have to go back. Yeah, so, but analyzing one single separate token is not interesting anymore. Of course, we can do it, and we will do it for all the tokens, hopefully. It's a matter of months just to analyze, see the probably issues, because AI is not perfect. Sometimes it has some errors. We need to fix that. We need to identify that. So we still, as token engineers, we still need it by AI to work correctly. But the main topic of interest here is a token value state, because it's a quantitative state of its value capturing ability. So what does it mean? It can change token value state. For example, we have a particular token at this point of time, but what can change in the future? For example, token design can change, right? There is proposal to add some new source of income, or to remove some functions, or to do something else. So, and we can track how this token design changes will affect token value right here, right now, because our AI already knows how token works, so we can know what will, if it will change, how it will affect all the metrics, probably. So, or if there are a lot of TVL inflow into the token, or sorry, into the project, we can see how fees are generated. So, or if there is some external influence. For example, if you will see like curve ecosystem, right? If curve receives more trading volumes and receives more fees, the vote scroll curve is more valuable. But the vote scroll curve is not on its own. It is owned by Convex Finance, StakeDAO, and yours. So it means that tokens of all these projects will also change its value state because they own the share of it. But not all people know that the yield basis, for example, will use some curve USD minting and borrow a lot of curve USD from curve. So it also will drive some fees to curve if yield basis will get some T value. So we can see these value connections between projects. And for example, we know this because the curve ecosystem is well studied, but there can be a lot of other value connections in other projects. So, and I think the future of token analysis is, mainly these 4 use cases. So I called first is a single player mode. So it's a precise analysis of one token. So then identify all the origins of value, mechanisms, metrics, how it really works. And, for example, why this token value changed in past, what events led to that. Also identify the value connections, and this is the multiplayer mode, like how tokens influence each other. For example, Uniswap influences Ethereum as layer 1. It's evident, right? For example, some projects built on Hyperliquid influence Hyperliquid. Some projects in DeFi that are connected through ownership or through maybe some LP tokens that are listed or some other source of connection. So we can see all these connections between tokens, and I think it's very interesting. And a lot of this stuff is still missing because it's not easy to see all these connections. Also, what if hypothesis testing? So imagine that you can ask, what if, for example, 1 billion of TVL will be deployed across top 10 DeFi protocols? To answer this question, you need to know all token designs of all these top 10 protocols, all metrics, everything. You need to know, and you need to build some, possible scenarios how this TVL will be distributed across these top 10 protocols and how it will affect fundamental token valuation. But now this task is maybe 1-2 weeks of of analyst work, or maybe more. But if you have an agent that have a deep context in all these tokens, because these tokens are already in the database with all the metrics, and we remember that ChatGPT doesn't have access to the on-chain metrics at least now, as I know. So you can have a much more possibilities. So this is not just token classification. You can really understand value on top of your hands, on your fingerprints, and of course. Theoretically, we can even prototype tokens in the future, because if you know all the tokens of all the projects, you know all the metrics, and you know how it worked before, what was user behavior, what was the amount of fee generated, or some other value generated, the market cap, how project in general worked, how product works. So you know everything. And if somebody comes to such kind of agent and asks, okay, I want to do such kind of project, could you provide me advice on the token design? It can provide 3 or 5 possible value capture mechanisms backed by a lot of data and some historical data, not just ideas or imagination. And you can probably even deploy it after that. Yeah. So for example, we also created a vibe analyzer. It's like a demonstration how it can work. You know vibe coding, so we decided to do a vibe analyzer, right? So vibe analyzer is that you can ask some simple question about any token which is in our database, and since AI knows all these tokens and all the structures, but no on-chain data for the majority of them at this moment, unfortunately. But anyway, even in this case, it can provide you some answers. So, for example, we ask what if there will be some TVL inflow in Vel, and we see that agent understands that TVL inflow will grow amount of fees will grow the value of governance, and all these connections and some calculations. Of course, this is like for fun product. It's not a financial advice or system that you can use to make real decisions for trading. But at least it at least shows that agent understands it and understands it quite well. If you plug metrics, if you plug even more data sources there, we can get much better results. And this is done really fast. So what can be done if there will be thousands of tokens with all the metrics? A decision can be much more knowledgeable. So you can go there, it's free. I will provide invite codes, so you can just play with it. But I need to give you an invite code. This is the only thing, but I have a lot of them, so I will be happy to give. And yeah, so the current stage. But what I also want to mention at the end, so what I think about the Web3 like value in general, I see that the Web3 value is like the big sky with a lot of stars, because we all know that stars are connected between each other with some gravitation and some all this kind of physics around it. So, and you can see one star, but you can also see some connections with other stars, planets, because all of this influences each other. So when you build this AI, when we build this token database and everything related to it, we try to build an observatory to see this star and finally understand what is going on there. So what we have now, at this moment, we can analyze one token in 10 minutes at almost zero cost. Of course, quality is different, but it's like 95% of correctness there, I can say. We plan to have at least 200 verified tokens at the end of the summer. Verified token means that we manually check everything and sure that it's correct entirely. And yeah, so please ping us, we will be happy to list your token, to edit, to see what AI will say about the token. So, thank you.
Thank you, Vasily. This was the second talk, and now we'll dive in. So we are not finished with exploring Valueverse, and we are also not finished with exploring Philip Zahn's concept. And the session lead for this TE Unplugged session is Mark Richardson. Welcome on stage. So I think I'll get you a mic. We have 3 of them. Philip is also here. So I think we are ready to start. Maybe, Mark, if you like to introduce yourself briefly, and then we kick it off. And of course, we are open to questions. Mark, feel free to prompt whenever you think we should provide some room for questions. Stage is yours. Welcome.
Thank you. Hello everyone. Thank you for joining us for this panel. My name is Mark Richardson. I'm the project lead at Banqua. I've been working there since the beginning of 2021 on an official contractor basis, and since 2020 first as an anonymous volunteer for the project. And I've been the project lead there since October of 2022. Vasily and I have known each other since way back in those days during sort of the early stages of TE Academy. And I think this is Phil and ours first opportunity to speak together. I wanted to premise this panel, what I see my purpose is here, because this is, I think, a little different from the kind of panels that you usually see at conferences, maybe not so much at ECC, but certainly at things like Token 2049 or something, where often the panelists are here to essentially pitch you on the strength, the investability of an idea or something like that. And it's the moderator's job to sort of make those ideas as compelling as possible or give the panelists room to present those ideas. That's not the case today. When Angela asked me to do this, she used the word peer review, which for me means to scrutinize and criticize. Right, it is the strengths of the ideas that we've seen our 2 speakers present will have to stand up to that scrutiny and criticism. Now that's not to say that it's mean-spirited, but it might not feel as pampering, I think as some panels often do. Now my other purpose is to bring some structure, right, to the conversation, some continuity, some shared synteny between the intellectual ideas that we've seen both of our speakers present. And from the outset, it seems that these are 2 very disparate topics. I'm going to try and convince you otherwise. I actually selected these 2 speakers as a part of the process leading up to today, so this is no accident. You were both handpicked, right, from a very long list of potential speakers, and I want you to know that I'm very pleased that you guys accepted this invitation, and it's my honor to be doing this process with you now. So I think the structure that I decided on and that I shared with you guys leading up to ECC is that we're essentially going to take the macro view that Vasily's expertise leans into, and then slowly sort of move down the funnel towards the the minutiae of the engineering decisions that Phil is explicitly dealing with. Now, Vasily, from Valueverse has sprung forth, I would say, from work that you've been doing since long before Valueverse would have been completely conceptualized. You presented, I think, just briefly, a familiar image to me, the sort of periodic table of tokens. I think a really good place to start this conversation would be if you could actually just tell the audience how that came about, maybe in the beginning stages of token engineering discussions, and like how long it took to even develop that and whether or not it's changed over time.
Yep. You mean the periodic table itself, or the just basic approach to distinguish origins of value mechanisms and implementations?
As you wish, but I think that the thing I want to drive at is that this periodic table is something that you're trying to discern intrinsic properties, right, of the value of a token. This isn't, you're not speculating on the price of a token necessarily. It's more exact than that.
Yeah. So I think all my work started at the point when I understood that discount token is not a separate class of tokens, but it is a conditional action, the amount of product that you bought or used with the discount and the amount of cash flow that you essentially saved from using some token as a discount token. So this was I think the first step when I started to think about all of this, because I understood this is not like discount token is not like a monolithic type of thing. It can be subdivided, and then I start to see consensus like work tokens, and the periodic table was much later, because so I created this origins of value and mechanisms, and I shared it with Angela, and so I shared it a lot, but there was no table, and Angela said me, Vasily, if you want to present it on some place, maybe it was a T-weekly reads. Because I shared a lot about the table that I will create it, but I never created. And she said me, if you will not create it, I cannot put you, invite you to this newsletter. I said, oh my God, I need to do it super fast. And I created it over 4 hours, because I understood that I have enough mechanisms that I identified to combine them into some structure that has some rows and stuff, and I can make some logic there. Not just put there to have some picture, but have a logic why this mechanism is in this like square. So this is how it happened.
Now when you first started speaking to me about that, I think around 2020, I think one of the pieces of feedback that I had for you then is that it's almost like you're imposing a superficially well-defined structure, right, over something that is continuous, right? Like it wasn't clear to me then, and maybe it's still not clear to me, that you can necessarily discretize the types of value capture in such a clean way, and that by doing so, you may be obfuscating some of the nuance there in the sort of continuum and how these things bleed over. One of the things you said to me then was like, yes, but these things compose together. Things don't necessarily fit into a single category, but they might belong to several different categories at the same time. I think I have a similar piece of criticism to give to you today, which is that with the AI models in particular, one of the things that they are demonstrably bad at is understanding nuance, right? And I wonder if you could comment for me on how much faith you actually have in the AI's ability to do the work that you have been doing, right, since 2020, in the sense that, the AI may not be able to detect the kind of hubris, right, that people inject into their white papers in order to describe their token that you might decide to remove from the analysis, whereas the AI is going to take it at face value, things like that.
Yeah, so for AI, I think the most important step, the first one is to identify all origins of value, distinct ones in the token, and second is to combine them into the mechanisms. And of course, the more verified cases that are like 100% correct we have, the better is AI. From one point of view. From other point of view, so we have a special like a database. What is, for example, the value transfer, right? In different projects that we are 100% sure that it's correct. And the AI see, okay, value transfer in Chainlink is this, value transfer in Ethereum is this, value transfer in USDT, sorry, in USDT we don't have value transfer. In Bitcoin is this, for example. So I think that like a lot of tokens on the market are similar. Even we have a lot of them, but they have different changes in design. For example, water scroll tokenomics, right? Very popular, like a family of mechanisms, right? We have curve, we have, for example, velodrome, we have aerodrome. If you will see, there are different structures, but the overall principle is the same. You lock token for a long time, aligning, incentives of the community and preventing some governance attacks, so you can, borrow token, vote for something bad, and return it on the lower price, efficiently shortening it, right? So I have faith in AI to analyze tokens and create like database records, but about the future investment analysis, I think it's much more complicated because it has much more factors than intrinsic value. So this is the like bigger pain point for me than just create a database. So I think creating a database is easier than creating results on top of the database.
Now, some of that nuance that, I'm not saying that I'm not confident that I'm not saying that the AI can't do it. I'm just saying my confidence is low, that I think AI is capable of understanding that level of nuance. And it relates to something that Phil had in his presentation as well. And so, Phil, I'd like to ask you to comment on this very briefly. But you pointed out that there is, we're going to talk a little bit more about some of the things that you mentioned, but specifically that there are design aspects to the debt market that you're hoping to create. Things like you said that there might be scores attached, right, to these NFT tokens, or maybe there won't be an NFT token. You mentioned that you might have a liquidity pool for secondary markets, which implies at least an ERC20 standard, or at the very least an ERC 1155 standard, and that it's possible, at least in I know I have a strong opinion about it, but I think that those specific design choices will actually impact the way that one of these tokens would be viewed under whether it's Vasily's rubric or any other rubric. And so I wanted to get your first whether or not you even agree with me. Like, do these specific design choices fundamentally impact the nature of the vehicle that you have at the end, or is it is it more well, you agree with me, so go ahead.
No, yes, that's the whole point. The whole point of, if it would not affect it, then we could just design one pipeline for everything, and it would go through, and then whatever happens. There are dimensions to it. One is, I mentioned at the very end, legal. Let's put that aside for now, because I think that's not relevant for what we're discussing now. The other one is also getting the liquidity into the market. So the question is, what are you actually selling, and who could be actually interested in buying it? And depending on the structure, again, if you think about the example on the construction yard, it's a very specific thing, very narrowly defined. How many actors in the market right now are able to actually think about the pricing for this thing? These exist, but they are specialized. So there's no point in trying to make it overcomplicated, trying to cater to a mass market in a sense, or trying to cater to non-sophisticated actors that do not have their own pricing in place. If you think about factoring, on the other hand, there are factoring companies in this world out there, and what they do is they basically provide a service for the companies involved, good or bad, let's put that aside. And then they are basically tapping into financial markets in different ways. They're refunding it through specific vehicles. They may be securitizing things. There might be also OTC sales to explicit actors in the market. On that regard, I think improving that pipeline, maybe creating more efficiency, is clearly something. But for that to work, you can't expect final people who buy this at all levels, except if you're really just, again, tapping into the same market as before. You can't expect them to do the pricing only on their own. So you need to provide information and have actors as basically intermediaries and as service providers in such a market in order to reach the end of that pipeline. Yeah, okay. You and I have consensus, I think, on this specific point. I want to push you a little bit farther, though, which is that one of the things that you sort of were a little bit ambiguous about during your presentation was that with respect to the risk property, right, of the debt itself, this is either something that you build into the at the protocol level, or you sort of allow market participants to shoulder the responsibility for that themselves. And I think that at a fundamental level, that's like night and day, right? That it changes the asset fundamentally. I was hoping you could discuss. Yes. Okay, so I agree with you. And in fact, the design we have is in some sense trying to accommodate this in the following way. When I said before that we have this digitalization process, which has its own risks, by the way, which I brushed a bit aside, that we just say it's solvable, and in a specific factoring case, it is. We can have a high degree of confidence of being solved. The question is basically, what is the instrument then doing? And let's say, give you a counter example to what we do. Let's say we would be directly saying this goes onto a pool. And then basically something in the pool happens. The problem with this is, depending on what you do, how does the pricing actually work? How, algorithmically, and is it actually accurate? Would it basically work in a market environment? So the idea is to have basically one step in between, which is the second module, this NFT step, where we basically take a very conservative and totally non-opinionated stance that we say each title is in itself idiosyncratic, which is not realistic, but it's basically a safety barrier, if you want. From that moment on, you can apply it, and you can say, look, I'm looking at this project, again, construction yard example, it's really idiosyncratic. There's no point in bunching it together. In other cases, like the invoice factoring for a specific segment of the market, which might be relatively risk-free at some level, it doesn't make sense to think everything is separate. But the idea of having this barrier in between is exactly for allowing different use cases and applying it and basically specializing it to the specific use case at hand.
Yes, okay. Vasily, okay. With respect, so one of the things that you mentioned in your presentation, and I wholeheartedly agree with you, right? One of the massive problems that we have is that there are so many tokens and there is so much information, and not even all of that information is good, right? There's probably equal parts information and disinformation, or maybe even more disinformation than actual information. And that's usually, like, when people hear that, it's very natural to assume that, okay, that's a one token per project problem. Like, you know, the fact that there's too many tokens might suggest that there's too many projects or something. But actually, the day has long come and gone where you can necessarily say that for each project there is one token, right? Even within the Curve universe, for example, there were things like, the Curve governance token, and then various wrappers on that through things like convex finance and other things. And so you end up with this entire, plethora of related tokens. And this is going to come back to something that Phil is doing, but I was wondering if I could get your comment just quickly on whether or not within that collection of related tokens that you can have like dramatically different sort of characteristics attached to each one of them in terms of the rubric that you're applying at Validator.
Sorry, I don't understand. The question is why we are sure that it's all correct in our database or not?
Just high level. Is it a reasonable expectation that all of the tokens associated with a single project will have a very similar sort of value characteristic according to the Valueverse rubric, or can you get arbitrarily different kinds of tokens?
Of course, we can get different because, for example, Curve has a V economics, and for example, Convex, they don't have V economics. You have just a vote lock. You don't have different duration there. So it looks similar, but works differently. And for example, Stake DAO, as I remember, is also V economics. I think that tokens can have totally different properties, and it is regulated only by the necessity of something. So you can even maybe create, the stable coin on top of Curve that uses Curve as collateral theoretically. But of course, maybe it's not a good choice because Curve is volatile and doesn't have a lot of liquidity for liquidations. We all understand that, but I mean, theoretically, you can even build some separate third-party stable coin on top of Curve token. This Curve token will be connected with the the stable coin will be connected with Curve, because if Curve value grows, you can mint more stable coin against it, use it more, farm more, get more fees.
Yeah, okay. And we haven't seen it, I think, with Curve, or maybe we have, but I might not be familiar enough with it, but certainly projects like Compound and Aave have very recently sort of overhauled, their tokenomics process and sort of decided that they want to discard, right, some of these auxiliary tokens that were created in the wake of the success that Curve was having with its, ecosystem, and instead sort of bring everything back to, having a single token. I wonder, when you see those kinds of consolidation processes, is it necessarily that you just kind of sum all of the characteristics, or are there these are these economies somehow less than the sum of their parts or more than the sum of their parts? Like, let's talk about this consolidation.
It's always different. So, for example, what I know about Aave, they introduced the proposal to add some protocol fees in the token, as I remember. So, and it significantly updates the future value state of the token, because we'll have a new source of income, which is evidently will boost the token, like at least some fundamental value that you can assume for it. So, and for Compound, as I remember, it was just a governance token where you have conditional action and governance, so you can just vote. You even don't need to stake, because it's just like you need to have a tokens before the date of the proposal, or the block of the proposal. And Uniswap copied this approach a long time ago. I don't know anything that is going with compound token, but with AI, hopefully we will automatically assume what is going on there. But I think that it's not a kind of consolidation. Probably it's they just build a new token on top of existing one, understanding all previous mistakes and problems that were there. For example, in our, you remember this safety model, right? That was paying first from emission, then as I remember from fees, and now they want to make fees for all token holders under some conditions. So because now it became evident that in DeFi, if you have a good fee stream, why not to share it with token holders if you can find a way to do that?
The reason I wanted to talk about this is that during Phil's presentation, you mentioned specifically, and in not much detail, and I understand in 20 minutes it's hard to get that kind of detail in. But you mentioned a sort of tranched marketplace, right, where you would expect certain risk levels, I think, to be distributed, or this is at least what I expected that you were referring to. And for each one of those tranches, right, this could either be represented by a unique ERC20 contract, for example, and this would resemble, I imagine that you're inspired by things like insurance-linked securities markets and how those are structured. And one of the questions, I've got a lot of questions about that, and it's possible that some of them can't be answered. But first of all, is my impression the correct one, right? Are you thinking rather than have NFTs representing specific debt, that rather someone puts together a prospectus or something, and that there's like a basket of these debts that are now under a specific ERC20 contract?
It's getting boring. Yes, you're right. Yeah.
Okay, good.
Maybe let me comment on the tranching. So again, this module 2, basically, where we make a conservative stance on each title being basically idiosyncratic, is just in some sense to keep the flexibility down the road if we are entering a market where the fungibility or the comparability, the similarity between different underlying titles is not automatically given. The whole point about having this standard second phase, basically, and tying it together with the risk assessment is to kind of get to a point where we can bundle things together in different ways. Now, there is, of course, a constraint. I'll give you an example. If the market basically supports, I make it up, 10 invoices per month, they are all wildly different. They have wildly different risks because we're talking about, a corporate doing the invoice and basically a startup doing the invoice. The risk will be wildly different. So one of the things that is very hard to predict and needs to be assessed on the spot for the specific market through quantitative reasoning and also for market design is how thick can the market be in principle. That depends on supply as well as demand. I think demand for yield is less of a problem, and in particular, if you can provide information and pricing actually can be supported and can become transparent over time. The question is the supply, and there is no recipe against it in some sense, just that you need to prepare. And in some cases, it might not even sense to set up the pipeline, right? If the volume is too little, then no point doing it. And then there is a secondary question. One is that if you think about it, traditionally, there might be actually reasons why these markets are small is because they're regionally clustered, even though if you compare regions, actually they're relatively similar. Again, you can make the case for Germany or your other European countries as well. So that one way of getting a thick enough market is actually by doing this kind of digitalization blockchain thing, because you're increasing the reach. This is a typical thing happening in, again, countries like Germany, where SMEs go to their local bank. Clearly that specific thing will not be well priced for them because they have a local, partial monopoly. Now, if you tap into a larger market, then it might actually be achievable that you have these tranches and they are thick enough that it actually makes sense to have them, right? Let's say we do an auction. Does it make sense to have an auction? And keep in mind, we're talking about things that are short-lived, 30, 60, 90 days. So you were thinking about the duration of a year. How many cycles actually can we auction off and synchronize? Which is not so, there are also details there which need to be taken into account. And then there is the pool, where, for instance, the synchronization of maturity is much simpler there because you don't basically can ignore it from the capital provision side. Sorry, I started off and I wandered off. Did I actually answer your question?
I think you've done, you got close enough to where I needed it. The reason why this is significant, first of all, is because we haven't, it's not true that tranched systems haven't already existed in DeFi before, right? You might recall, like Barnbridge, for example, I think was the first to implement something that was like the splitting image of something that you might see in traditional finance. And they also had ERC20 contracts specific to each tranche. And so, Vasily, back over to you. If we were to apply the rubric, right, from Valueverse, let's say that that you were hired as like a consultant, right, to advise on a project like this. Obviously, there are all kinds of decisions that need to be made here. Some of them are about practicability and engineering, implementation challenges, and smart contract security. And some of those things aren't necessarily always aligned with the value capture properties of the token and the system itself and things like that. And so I wanted to ask, in a general sort of sense, what would be your objective advice, right, for structuring these kinds of things? Do you always prioritize, right, or is it true that you can even prioritize the categorization of the token of tokens underneath the rubric that you've developed, or is it more pragmatic than that? Do you sometimes need to say, well, it might not look like it has the best value capture now, but at least it's implementable, that sort of thing?
Yeah, Mark, as I understand, the question is how to design an utility token for this project on top of all these, depths that will be created. So depth itself is a representation. So the token, the NFT token representing the depth, is a representation of real depth, which is, existing, right? This depth, it has some recurring payments, it has some interest rate. If the interest rate is, positive, not negative, it means that we have some future cash flow. If I own a debt, assuming the debt will be fully paid with all the interest rate, I will get a cash flow, right? So I see this as a representation and a future cash flow, and all the technical instruments that I used, oracles, smart contracts as well, they're all built around making this representation working well, I think. Because you need to know the price, you need to calculate the default score, like there's some chance that will be defaulted. So this is basically a representation, and using all these oracles, you try to notify owner of this token about the real, properties of the debt, what is really going on. So, and on top of this, debt universe, right? You have thousands or hundreds of thousands of debts. If this system will be scaled enough, right, it will work well, for example. So it means that. And you also want to make these tranches because you can combine it to the pools. If you have a lot of debts with similar properties, you can combine it into the pools. So what we have here a lot of cash flow, so you can distribute some cash flow to token holders, but of course it's evident. Do we have some governance possibility? I don't know, but I think that probably you can also get an access of people who can create debt and maybe underwrite debt in this system and make some money on that, because it's something that is not you cannot allow everyone to issue debt, right? You can allow everyone to underwrite debt, for example. So I think you get a cash flow in some form. I mean, if you, for example, do a buyback and burn, or you do some direct dividends, or you do something else, it's anyway cash flow. Even if you do a discount, it's also a cash flow, but paid in natural form. So I always understand that this is a cash flow. So you have a cash flow in some variation, you have governance, you have an access. So this is three type of origins of value that I see from the first side. Maybe there is a chance to do some kind of water scroll, because I mean, why water scroll is so popular? Because I mean, owners want people to lock tokens, right? Because they want to avoid selling. But this is for speculators. But we at the same time we understand that these token lockups for a long time protecting the system from governance attacks, and this because if you lock the token for a long time, you don't have any motivation to vote in a way that will crash your system. I mean, this is the assumption in general. Of course, there are some bribes, and we saw how in Curve, for example, bribes change it. The whole understanding of what people want to vote for and how. So, I think if you will ask me how to do the token, and we go for a coffee for 1 hour, and we'll sit and just think from scratch, just some friendly advice, no responsibility for that, right? For example, I will do what's called tokenomics, will get some fees from it to make token holders also getting some profits, for example. Also will provide some discounts. If you have a big word scroll position, you have some discount on something, because I think there are some services and the governance, for example, on the register of people who can issue debt, who can underwrite debt, and you also need to have some staking tokens that can be alienated for doing these actions, because if you do these actions incorrectly, for example, you do on purpose not correct underwriting of debt or something, you can be slashed, for example. So something like this.
Of course. Thanks. Maybe let me tie into something which I think is very much related on evaluation and also about the tooling we heard about. One of the advantages of doing something what we do in principle, not immediately but down the road, is obviously also the traceability and the transparency of information that gets basically assembled over time. And one of the questions that we have right from the start, and which is, you can't answer it basically purely theoretically, but you have to also explore it and you have to try it out at some level, is what information is actually needed for which parties and for what specific scenario. Providing this information, though, is obviously important in a way that you can actually inform the pricing along the chain. So again, if you're moving things by chain, I mean the finance supply chain in some sense. So party A, party B has debt, and then sending it to C, maybe to D. And as you mentioned, there might be securitization steps, there might be other forms of refunding happening, which change the nature of the instrument, and which might also, we have seen this, 2007, 2008, that information basically is lost, and that causes a lot of trouble in the pricing. And one of the goals clearly is not to do that, but instead to have a way and identify information that is actually relevant. That's also linking up to you. I mean, if you have pricing models basically that require certain information, that information is not there, and it might be not obvious, totally obvious that the information should be provided at the beginning. Over time, it should actually be provided. So there is it's not, that thing is not we're designing it and, let's go to the holiday and goodbye. We will not, it is meant to evolve, and there are many questions in the specific information, but also in the structuring that we will evolve over time.
Well, I'm glad you brought that up, because it was one of the things that I wrote down very early in your talk, when you said that you had listed a few of the attributes of tokens being like standard and composable and this kind of thing, and that the code base that you're developing, or the framework that you're developing, is intended to be modular, reusable, upgradable, this kind of thing. And it's it's again one of these cases where particularly at the speed at which blockchain development moves, versioning becomes a huge problem, right? And it seems like you're saying two different things, right? Because on the one hand, when you're trying to produce a monolithic standard that's supposed to exist in perpetuity, like Simon de la Rivier's ERC20 standard, right, which was perfect when it was created and will be perfect for the rest of human existence. And then what you're saying is, okay, we like this idea because we can reuse this thing, and this is why we're attracted to this paradigm. But then say that, well, but we expect to evolve over time, these kinds of things. Like, resolve this conflict for me.
I mean, I don't see a conflict, honestly, because first of all, I said before, it's work in progress. It's not like the thing is deployed and we shipped it and that's it. The thing that we are designing at the moment, it's really in a development phase. So the classical distinction between development, testing, deployment, that's similar what I see here. But the question is, if we are now designing, let's say, a fully fleshed out pipeline that is basically monolithic from end to end, then we test it and we feel, oh, this works. But then the lawyer comes along and says, guys, what are you doing? So in some sense, the fact that it's modular and modifiable is exactly for, in the first phase of setting it and adapting it to a specific market, it has to evolve up to a point where we can test it and where we can verify, yes, it's working in an effective way. It actually creates a thick market. It's actually legally sound also. We got basically cleared. It's regulatory sound. That's why we want to have a building block, that we can adapt it to a specific scenario, can evolve it. Eventually, of course, in that specific market, it should mature, and then it should not be about, hey, we're changing, to version 5 in one go. It should be stable. But at the moment, I think there's a lot of uncertainty about many of these components. And that's why we emphasize this. And maybe also on the market design side, there's a contingency. Depending on what you structure in the beginning, let's say the primary market has a lot of effects, legally, regulatory, but also technically, what you can do just from a market design perspective for the secondary market. And we have to be careful. If we now basically make a choice, this is it, that's the component, we are not changing it, what do we do then? Right? If there is no secondary market, maybe there is no demand for it, then we would be stuck.
I feel like you may have started making some of those decisions already, right? For example, you mentioned that in your modules you had, I think number 1 was the oracle, right? This is an irreversible design choice once it's built into it in general, you also had, I remember you struck off a couple of things, but then the secondary market, I think, was point number 5-ish or something on the list. And then on the next slide is where we sort of went into the ambiguity between NFTs or whether or not we're going to have liquidity pools and that sort of thing. So, okay, fine. Maybe there is no conflict with respect to versioning, and I concede the point. I do think that there's a conflict between oracle pricing and liquidity pool-based pricing in certain circumstances. Obviously, not across the board, but I want clarity from you on that specific point, because if you are using something like an oracle price feed, first of all, what do you mean, right? Is the oracle just providing off-chain data in terms of that the risk has been evaluated as a certain number, or does this, what is the oracle doing there? And then, how do you see that participating in a liquidity pool-based secondary market?
Okay, I mean, in principle, there are two. I mean, I didn't say it explicitly, but the risk module itself might be an oracle. You can conceive it like that. The first oracle basically has a much more primitive thing. I'm a construction company. How can you make sure that the contract actually exists between me and the other company? It's a very mundane thing. Is the invoice that in the factoring case I want to basically factor, is it actually real or not? That's basically it. It's basically about proving that there is some kind of, let's call it asset or underlying that I'm basically want to base my claim on, my token claim, that it actually exists. Now, to be fair, and I agree with you, this is not harmless at all. In the specific factoring use case, we basically bypass the whole problem because, as I mentioned initially, in that specific use case, there is a government-enforced system that if you're uploading your invoice and you're tampering with it, you are in deep trouble. So we can basically, it does not mean that you get money back, and there could be other reasons, and we have to think about this. But in some sense, the whole problem is orders of magnitude simpler at some level, specific for also if you don't start, if you whitelist companies basically active in that system. On the pricing itself, on the risk assessment, yes. So this is actually one of the things we have question marks. It is clear to us that let's say for the factoring case, we actually need some form of assessment from third parties. And obviously what we do, let's say we are building a pool, and what do we do actually if the assessment is just bad or wrong? Now, first of all, we have to think about ways of how to ensure the quality. This is basically off-chain. This is just good business operations doing it. Moving forward and thinking more long-term, you can also think about gathering information about this. In principle, it's not easy, but in principle it's doable, and it actually ties also into an evaluation. Are these risk assessments actually correct? Because, think about the instrument we have, right? You get a payment at the beginning, and then you have to do a payment at the end, basically a coupon, right? So it's structurally very simple. This is, let's say, 90 days. And you either make it, it's incomplete, or you basically default. So the typical thing is a relatively simple risk in the sense of mathematically risking it. You need basically a risk score of how high is the probability of default or only partial payment. In principle now, if you're collecting enough information over time, you should be able to say that service provider XYZ was actually doing a miserable job because they qualified things as A and it turned out to be actually D, right? I'm making it similar that it is. There are lots of practical problems, operational problems on the quantitative side to actually make this true, but at least it's an opening up a design space that you can do and use over time. Now, what this is not solving is the problem of how do you deal with it short term, right? So you need to have some mechanisms in place that if the defaulting goes overhand, which would be an indicator that something is not priced accordingly, that you have to intervene. And this is one of the things we are struggling with. Yeah, I think I'll stop here, and you can ask executive questions.
Totally reasonable. I want to throw a discussion back to Vasily for a moment. And I think I just want to ask a plain question, which is like, what is the purpose of value reverse, right? Like, do you present it as like a consulting company, right, for crypto projects to use, or is this more like an information provider that people are supposed to approach the way they would something like Wikipedia?
I think that the Valueverse is a data company, I think. our main asset is comprehensive understanding of hundreds or thousands of tokens, which are really needed by someone. I think this is the core, and anything that you can build on top. I mean, the valuation models, any kind of AI like predictions for price or something is just a products on top. Our main goal is to very correctly assess what we have in the token. I think this is the most important piece of the work, because if this foundation is not correct, we cannot build anything on top. So it's not a consultancy. I'm trying to focus not on consultancy anymore. I try to focus on building this. I want in 6 months that you can just come and build token with AI. This is much more interesting, I think, than just a consultancy. So, but one of the questions is why the information in our database is correct. Because we can, even, if you have AI, it can read, some outdated contracts, outdated website, information can be incorrect. This is a very good question. And to be perfect, it should have, like kind of digitalizedly curated knowledge graph or something. This is, I think, the next big step that I will need to do in the future. Because now I just showed the general principle how we can decompose token and how can we scale it. It was not, kind of, shilling the project itself. It was more showing that, the approach that I established, that it really works at this moment. But this is only a piece. Of course, I understand that now we have a centralized Oracle, and centralized Oracle is CoinGecko API, right? We rely on it. We trust that CoinGecko provides us true links to the website of the project, right? To the documentation. We trust to the project team that the documentation is correct and that contracts are correct. Maybe there are some new contracts that are not listed at all, right? Maybe we can. So this is all the assumptions, and we understand it now. We fully understand it now. We just, every database record is our vision of the token and like our vision of what we found as information about it. Maybe it's different. So.
Okay. So let's say that we went with a type of, specific custom utility token, right? That somehow captures let's say the profitability, right, of the debt market. And the things that we list off are essentially, that it's Oracle, it's external Oracle dependent, and there are risk assessors, and I forgot to get clarity on this, but it sounded like that there is a field where the risk rating becomes like a stuck to the thing, which implies that there are administrative permissions on the token contract, and combined with that, we assume that there are we heard from Phil himself, massive like legal and regulatory barriers to getting this done. Like altogether, I would say whatever this token would be or tokens would be, it's looking extremely complex, right? Do you think that the analytical framework that you have today, right, would be able to handle something of that level of complexity? Like to what extent do those design implementation decisions impact the score or whatever you would give to this thing?
I think that it depends on the quality of documentation, basically. But
actually, a perfect answer.
But let's think about. So I propose it. I mean, like a friendly advice and joke without no responsibility. I propose some token design, but we all understand that the value of this token will be tied to amount of defaults, because the more defaults is there, the less cash flow this token will get, right? And less will be like the value of underwriting all these debts. Less will be the value of issuing new debts. If you have a platform where a lot of debts getting to default, so it means that lenders getting nothing. That means that the trust is going down. Nobody wants to go because your initial risk assessment is not correct. So, yeah, I just want to add some like on top that all this value capturing, origins of value mechanisms and stuff. They're based on the percentage of defaults. If there is too big percentage of defaults, it all goes to zero. I mean, the fundamental value of it.
Yeah, maybe one thing on this. So when we started this project, this originally originated quite a long time ago as a research project mostly. And initially we were kind of really thinking about, can we do something radically new on the token design? Maybe think about what could be the token here. I mean, you saw what we do now, which is relatively standard. And one of the reasons obviously is that if you come up with something fancy-pantsy, then who understands what it actually is? What are the risks involved? And I mean, as you said, basically, that's part of the documentation. If you use standards that are well understood at some level, that's not enough. But of course, it makes it easier for people and also for systems to understand what are the consequences of this, and also goes through simulations basically, right? The thing that I would maybe also kind of prompt from my side is that I mentioned and alluded to that the legal risks are hard. This is specifically if you go cross country, where your underlying is a debt relationship between country A and country B, or parties in country A and parties in country B. The practice of going to court and basically enforcing some invoice can vary dramatically depending on where you are, right? And this is one of the things where it's very hard, and this is something also professionals on the pricing side struggle with a lot. What is the price? And I think AI actually could have a big advantage on this, because if you have enough data and collect it on all levels, there could actually be a way where you can price something better, which is very much highly unstructured, right? I mean, a zero coupon bond is structured and relatively straightforward.
I just want to add a few seconds. So your debt is a representation. Everything you build is ensuring quality of the representation. Your interest rate is your future cash flow, and your pooling is a meta representation that collects all the chances of default. So basically, from the value capturing view, it's very simple. The question is about the implementation, how it really works, and this is much more complicated. But if I build this, what I will think about, I will think about to do this project inside one jurisdiction, like European Union, right? You can make invoice between Netherlands and Germany, like countries that are quite close and they understand legislation. Inside the United States, you have a lot of states and people inside. You can do it inside the United States. So the cross-border invoices, I think maybe it's the step 2 only.
Thank you, gentlemen. We're going to have to leave the conversation here. Audience, please join me in thanking our panelists. I think this was a terrific conversation.
Thank you so much. Big thank you to Vasily Zumanov, Philip Zahn, and Mark Richardson. And I think it was quite obvious and so tangible in this session, this live freestyle token design session, that you start with something, let's say a simple model, and you feel like, okay, let's pile up all the fancy mechanisms we have on our hands, and then end up with a lot of design choices to make and potentially a lot of complexity that gets harder and harder to handle. So thanks for sharing your thoughts here and sharing this little token design journey. And thanks for prompting it, Mark. All right. Our final block of talks. This one, the last one, is about, go on stage, is about validation and verification. I give a brief overview on what you can expect now. Our first speaker is William George. Welcome. He talks about peer prediction and Schelling point oracles. And the second talk will be Juan Chianchi, JP from Cosmos Ventures, talking about a methodology for pricing gas options in blockchain protocols. And the following TE Unplugged session will be hosted by Chris Peruch. And the topic is incentives at the edge, valuation and verification in crypto protocols. So this is our final block at the token engineering track. And we start with William. Let's give him a warm welcome. Excited for your talk.
Great. Can I put the slides? Great. Can I go back? Okay. Great. So thanks everybody for being here. My name is William George. I'm a mathematician. I work with the Claros Cooperative. So today I'm going to be talking about peer prediction and Schelling point oracles. So what does that mean? I'll describe what both of those things are and how they're related to each other. So first I'll give just a brief description of what the Claros protocol is, as it sort of motivates what I do, and what I hope will be illustrative. So the basic idea of Claros is it's a dispute resolution protocol. Imagine that you have Alice, a small business owner, who's hired John, a freelancer, to build her a website or something. And the idea is, like Alice puts the payment for John into a smart contract escrow. If John does a good job, just Alice clicks a button, the payment's released. If John does a bad job or Alice doesn't agree about the quality of John's work, then they go to some kind of dispute where some random collection of Claros users are drawn and they vote on who is right between Alice and John. And they vote using what we call a Schelling point principle, alternatively called a focal point. So this is an idea that is due to Thomas Schelling, who's an economist. He won the Nobel Prize. And he had this idea that in the absence of communication, if people are trying to coordinate, they'll drift towards solutions that seem socially natural or special somehow. So that's kind of abstract. His like classic example that he used was that if people are trying to meet in New York City and they don't know where to meet, they will tend to go to the information desk at Grand Central Station. Well, why? It's just kind of a distinguished meeting place. You go there expecting the other person also to think that maybe you would go to Grand Central Station, and you expect that they expect that you expect whatever. And then the idea in Schelling point oracles like Claros is that the people are voting, they're incentivized to agree with the group, to agree with the other voters, maybe with like an appeal or whatever. So they'll imagine, okay, the other voters are going to look at the case, they're going to think that Alice is right. I'm going to vote for Alice, expecting them to vote for Alice, expecting me to vote for Alice. Okay, so that's a Schelling point oracle. This is inspired by, among other things, a blog post that Vitalik wrote back at the dawn of Ethereum in like 2014 that he called Schelling Coin. Other crypto projects use similar systems, UMA, etc. Okay, so and just to like comment that like this structure exists in other crypto economic systems as well. So this is already an example that was in Vitalik's blog post from the previous page, that in block production, you're kind of playing a Schelling game. In that, imagine you have some kind of fork. This was particularly true in proof-of-work systems. It's still kind of true in proof-of-stake systems. And you're trying to produce the next block. You don't know whether the community is going to like recognize two competing histories for what the previous block was, but you want to pick the one that you think will make it onto the chain because that will increase your total rewards. So ultimately, you pick one fork or the other, hoping that other people will pick the same fork as you using sort of Schelling coin principles. Okay, so what's peer prediction? Well, peer prediction is an academic field that's at the boundary of computer science and economics that studies crowdsourcing and how to provide micro-incentives for crowds to answer questions, usually by incentivizing them to agree with other peers that are also answering the same question. So that sounds like exactly the same thing, right? That's a highly related problem. There's this rich history of peer prediction literature, and that is not widely being used in blockchain systems, and the question is why. And in the rest of the talk, I'm going to talk about some of that work, why it can be difficultly applied to blockchain systems, and maybe how we can glean some ideas that we can actually use. So there are different kinds of peer prediction mechanisms. Different people have different mechanisms. So again, a rich literature. A classic thing to do is to ask people two questions. What is the right answer to the question? Who was right in the dispute between Alice and John? And also, what percentage of the other participants do you think will vote for each answer? So maybe I say that John is right, and I think that 60% of people will vote for John and 40% of people will vote for Alice. You can do really cute things with this. So this is a famous example. Some of you may already be familiar with this. But there's this classic example due to Prelec, where the question is, what is the capital of the U.S. state of Pennsylvania? And then you answer that question. You also say what percentage, what you think other people will say, what percentage will vote for each possible choice. And the thing here is that it's kind of a trick question. If you don't know the answer to this question, you might think that the capital of Pennsylvania is Philadelphia, because Philadelphia is an old historic city in the United States. It's a big city. It's very, very old. Lots of history. It's the kind of place you might have expected to be a state capital, but it is not. Harrisburg is the state capital. So the people who don't know the answer to the question will vote for Philadelphia, and they'll think the other people will also vote for Philadelphia. The people who do know the answer to the question will vote for Harrisburg, and then they will realize there's this thing about people voting for Philadelphia, so they'll say that the people will disproportionately vote for Philadelphia. So Harrisburg winds up being surprisingly popular, and you can pick out stuff from this asymmetry in how people vote to come up with really interesting voting and incentive systems. Maybe you realize that Harrisburg is the winner because there's this enlightened collection of minority experts, even though only a minority of people voted for Harrisburg. The majority of people were wrong. Then if you deploy that in blockchain land, naively, you run into all kinds of problems related to 51% attacks and such. Our identity systems are weak. it's hard to have like really strong notions of identity. Like people can get multiple votes, pretending to be multiple people, and like maybe what the system might think is being this like collection of minority experts is actually an attacker who's attacking your system. So here the attacker is saying, okay, I think the answer is Pittsburgh, and those people voting for Harrisburg, they're the like the sheep that like don't know the real answer, and your system won't be able to pick this out. So ultimately, like these systems all have different assumptions about collusion resistance that may or may not be more applicable to blockchain systems, and unfortunately, a lot of the really cool existing stuff just does not have the collusion resistance that we would need in our world. Another sort of more formula-based mechanism that I'm going to like draw from in the following slides is called robust Bayesian truth serum. It's from a paper from Radanovic and Feltings. So here you decompose the incentive people get into an information score and a prediction score. Their information score in this mechanism basically just tells if they agreed with a peer. You randomly pick some other voter and you see if they agree. If you agree with your random peer, then you get a reward. The prediction score follows this formula in the second line, this like R equals blah, blah, blah. It incentivizes you to provide good predictions for like what percent of like 60% will vote for Alice, 40% will vote for Bob. It uses the magic of scoring rules to like incentivize that well. I'm not really gonna go into that, but that's sort of what that's doing. There's this interesting sort of technical point here that in most peer prediction papers, people compare the voter to a random peer. In most blockchain applications, like Claros, usually you're compared to a collective outcome. You're compared to like the winner, possibly with appeal, like what block made it into the final chain. And there's a question of whether that's like an important distinction. Like I feel talking to peer prediction researchers, usually the like peer prediction people like compared to the random peer, mostly for mathematical convenience. You don't really have to go into the weeds of what the like aggregation rule is to determine who won the dispute. You can just purely focus on the incentive system without having to worry too much about the like voting system. But I'll come back to this point briefly maybe later. So like peer prediction researchers have tried to like do stuff that's more related to blockchains. There are a couple of these papers here that try to do peer prediction that's more attack resistant. Because you have these extra constraints, it's somewhat more limited. I think both of these papers are restricted to cases that are binary, so you only have two choices. There's these other cool papers, like the one on the binary report peer prediction for real valued single spaces is actually a negative result that says like, you cannot do this. If you try to do this, you will never find like the good equilibrium. The thing about the verifier's dilemma is peer prediction for a very specific game that's like verifying in rollups. So people are doing more and more, and I'm going to spend the rest of the talk sharing stuff that I've been thinking about, that like how we might adapt some of these ideas. So this is motivated by a specific problem that we have in Claros, or a specific thing we've observed, that sometimes you have categories of cases that have really unbalanced rates at which people win. Imagine you have a bunch of cases which are like a business versus some series of their clients, and like a user can look at the statistics of the past cases and realize, okay, like 97% of the time the business wins. Like they have a team of lawyers and they're like super professional in what cases they like bother to bring to dispute, and like all their arguments are really well written. We have cases like this where businesses have outsourced some of their consumer dispute resolution. Like there's this Argentinian crypto exchange called Lemon that does stuff like this, and they win most of the time. And then how do you prevent the jurors from just always voting for the business? They're going to be right 97% of the time, and our traditional approach to this is to just tweak the parameters. So we have two parameters, among others, that are relevant here. The fees the jurors are paid and the deposits they lose if they're wrong. And the idea is that you just like raise the deposit. Yeah, okay, maybe you're right 97% of the time if you just always vote for the business. But if you take the effort to like really analyze the case and do a good job, maybe you'll be right 99% of the time. And the deposit is so big that the right difference between 97 and 99 is the difference between being unprofitable and profitable. And the problem with that is that if like the cases are really unbalanced, like really you get close to 100% of some category like winning, the deposits become quite large, which can be unfortunate for risk-averse jurors. So yeah, okay, like maybe you'll average out and you'll win on average. You know, like I do a bunch of cases and I get slashed for 100 euros once, and I make a bunch of micro payments of 5 euros. But like, if you're looking at that on the screen, you're like, okay, if I'm right, I get 5 euros, and I'm wrong, I get 100 euros. That's not maybe a great experience, even if like on the whole it averages out. Like people treat losses usually as hurting more. So like you can adjust your utility function with this like lambda factor that weights the losses more. And then something I thought about doing is this mechanism here, where basically, you know, this looks like the peer prediction stuff from a couple slides ago. The prediction scores is completely the same. So again, like jurors are asked to provide a prediction for like, you know, 60% will vote for the company, 40% will vote for the client. What's interesting is, well, I think is interesting, is the information score, where in this mechanism, if you're right, you just get a flat fee. And if you're wrong, the deposit you lose is weighted by the prediction score of your peer. And the idea here is that if the peer says that the case is like kind of fuzzy, it's hard, you know, I think it's a 50-50 case, and you're wrong, then the system is generous with you. It doesn't slash you too much. If the peer says that the system is like, this is clear cut, the client is clearly right, and I'm wrong anyway, slashed. So that, you know, if I'm the honest juror, you know, I'm gonna be right, like most of the cases are gonna be clear cut, I'm gonna be right most of the time, whatever. The cases where I'm wrong were probably the hard cases, so I'm not penalized too much. If I'm using the lazy strategy, well, because I don't know whether the case was clear cut or not, because I didn't bother to read it in depth, I will be penalized like the big slash more frequently. And you can use that, you can put that together to come up with parameters that are better for risk-averse participants. And then just in the sort of remaining time I have, just to talk about some things that come out of this that, you know, raise future discussion. The kinds of attacks that we at least have observed on the system are interesting, and that most of like the new attacks are what are called griefs. So if you're not familiar with griefs, this is again due to a blog article by Vitalik from many years ago, where he defines this notion of grief as being an attack where the attacker is willing to take on an economic cost to themselves in order to harm others. The word grief, I think, comes from the language of video games, where you have players that are just kind of like trolling others and they're not like actually advancing their own interests in the game. And he defines a griefing factor as like the harm you do versus the cost that you take. So if I can do €1 of cost to myself to do €1 of harm to others, that's not great, but it's, you know, not a big deal. If I can spend €1 to do like €1,000,000 of harm, then like someone is evidently, you know, definitely going to do that, because there will be a troll that is willing to watch the world burn, and they're going to spend money to do so. And then in the mechanism that I'm considering, you know, what happens if you provide the wrong prediction scores? Well, you can say that a case is more clear-cut than it actually is, and maybe the case is actually 60-40 for the business, and the attacker is like, this is so clear-cut, it's 99-1. So without going too much into the depth of the computation, you can look at how much this costs the attacker. They're penalizing the prediction score because they're providing a prediction which is wrong. Like it is misaligned from what people are actually going to vote. So it has some cost, it does some harm, because if the person they're paired with disagrees with them, then they will be slashed where they necessarily shouldn't have been, or like the penalty will be bigger. And then you can wind up showing that the griefing factor is 0.5-ish over alpha, where alpha is a parameter that weights how much the information score is compared to the prediction score. So the bigger alpha is, the more prediction score matters compared to the info score, which makes sense here. And that if like alpha is really big, then the prediction score counts for a lot, so the fact that the attacker is providing bad predictions is going to hurt them, so it makes their cost higher. So coming back to this point about like, why do I compare to a random peer versus comparing to the collective outcome? Again, the peer prediction people, I think, mostly just do the comparisons to random peers for mathematical convenience. But when you compare to the collective outcome, it's harder to do the kind of grief that I just described. You know, like if the attacker provides the wrong prediction score, then like if I'm pairing them with a random peer, like some random peer is going to have the misfortune of having this like very wrong prediction score provided to them. If you say take the median, if you take aggregate information from the whole panel of the prediction scores, then like when I'm being compared to the median, the attacker only has limited ability to manipulate that, which is not to say no ability to manipulate the median. So I have this revised mechanism where I take, instead of like the peer's choice, the winning choice is my point of comparison, and the median prediction scores as opposed to like individual people's prediction scores. And then when you try to analyze the attacks here, you wind up having a similar attack model to basically the attack models on oracles for similar values. So like the prediction score is a number. That the system is like aggregating people's prediction scores together and is ultimately coming up with this intermediate value that's using that, you know, to incentivize people. And it has an attack model which is very similar to the attack model if you were to use an oracle for number values that takes the median of people's numbers they submit. So if you imagine that like there's some distribution of what different predictions people are going to make, you know, inevitably they're not all going to make exactly the same prediction. In the absence of attack, you know, the outcome is whatever. And if the attacker is sophisticated and can predict, okay, like the distribution is this, if I'm trying to like grief people by changing the prediction scores so that you know, like people think that, so that like their the measure of whether the task is clear cut or not is erroneous for people's comparisons, then I'll put my votes, maybe I've got multiple votes, someplace like on the edge, just big enough to like drag the median up a little bit and have some impact on other people. And then ultimately, like what the griefing factor here is depends on exactly what the distribution of what people vote are. So, okay. Then I compare the mechanism that I've considered to like a default mechanism that just gives like flat payoffs. You're F if you're right, minus D if you're wrong. And I have a model where I say that, okay, like tasks, I have tasks of various difficulty, how good the jurors are, the voters are at determining the right answer. It depends on how much effort they put in. There's this like exponential function that determines how their rate of success, yada yada. And I have a theorem that says that, okay, if I have some participants with risk aversion, in some parameter choices, then the peer prediction mechanism does have this property that I sort of claimed earlier, that it requires smaller average penalties to deter lazy strategies so that it is better for risk-averse participants. Okay, then to wrap up, lots of interesting academic literature on crowdsourcing with peer prediction. It's hyper relevant to oracle design, maybe also to consensus algorithms, anywhere where you have coordination in our space. And it's not widely used in crypto due to weaknesses about collusion. There's newer work that tries to deal with those limits. And I'm trying to think outside the box. So I hope, you know, if other people are designing mechanisms in this room that like, you know, maybe you can think of like a peer prediction application for your mechanism. Like ultimately, like the mechanism I proposed is not, you know, like the attacks don't change what answer is seen as right. Like I'm rewarded, you know, if Alice wins, I'm rewarded for voting for Alice, you know, whether the attacker is griefing me by like making the case look less or more or less clear cut. The only thing they can do is raise the stakes for other people. So that's like a not so bad attack that you're willing to tolerate maybe in your system. So more compatible with the kinds of attack models we have. And ultimately, you know, so we have this, you know, slightly different approach for peer prediction. What other different approaches could we have? Okay, so I wrap up there. I look forward to the panel later on.
William. This was amazing. In case you guys have questions, then definitely stick around for the TE Unplugged session where we have plenty of time to dive in. For now, I'd like to welcome JP on stage to present a new methodology for pricing gas options in blockchain protocols. Juan, welcome.
Let me just figure out how to use this real quick. Okay, cool. Thanks everyone for joining. My name is JP. Today I'll be presenting a talk entitled A Methodology for Pricing Gas Options in Blockchain Protocols. So yeah, let's get started. So as we know, blockchains like Ethereum require gas fees to execute transactions. Now, the problem is that these gas fees can get extremely volatile. They can spike unexpectedly during periods of high congestion, and they can also be quite multi-scale. So if you look at this part here, you see that it oscillates around 0.1 for the first 1,000 steps, which is not that much, but then it quickly grows 1 or 2 orders of magnitude and oscillates around that. And of course, this creates unpredictability, and unpredictability is a major hurdle for different types of users, such as everyday users trying to send their normal transactions, large-scale DeFi platforms managing operational costs, as well as institutional adoption, which requires cost predictability. So with this in mind, trying to solve this problem, we developed a way for participants to hedge against this volatility. And there are multiple ways of doing this, but one of them is using options. So just a quick recap, an option is a contract that gives its holder the possibility, the option, but not the obligation of buying something at a future date at a preferential price. And in this case, the something would be block space. And options in blockchains are not new. There have been some attempts to it, but options that have to deal with block space have been mostly dominated by methodologies that use predetermined statistical models. So one of them is ARIMA models. I don't know if you're familiar with the Euler network, but they use ARIMA models to fit the gas. So basically what they do is they fit a statistical model or some parameters to the base fee. Or some other literature use Ornstein-Uhlenbeck processes, which if you are a physicist or if you're familiar with stochastic simulations, you can recognize this. And if you're not, just think about it as like this mean reverting process, right? Like kind of like a mass spring type of system. So something that oscillates around a given point. And the key issue with this is that they fit a predetermined parameter to something that has different dynamics, right? So they ignore the specific discrete rules that govern how gas fees actually change over time. So as such, they failed to capture the true data-driven nature of the fee update mechanism, namely the EIP 1559, and as a result, they often misrepresent the fee dynamics, which results in a misprice of the option. So our contribution from our work is that we propose a new model that is built directly on the blockchain's own rules and historical data, leading to more realistic simulations and pricing. So just before we proceed, I'm just going to give 2 parts of review. So the first one is just going to talk a little bit about 1559, and then I'm going to talk a little bit about how to price options using martingale pricing. So for the 1559, we know that the base fee, B of t here, it evolves according to this formula, right? So the base fee at the next block is equal to the base fee at the current block times this factor here, where phi is some step size currently set at 1/8 if you are on Ethereum. And this term here is the gas used minus target divided by target is the relative gas usage, which with the convention that gas usage is a number between 0 and twice the target, okay? And for notational simplicity, I'm calling this whole quantity x of t. So from this, we have that x of t is this number that lives between -1 and 1 that measures how full any given block is relative to its target block size. And intuitively, this is fairly simple, right? If the block is over half full, it signals that it is congested and the base fee increases for the next epoch. Conversely, if the block is under 50% full, it signals that the network is not congested and the fee decreases at the next epoch. And lastly, if the block is exactly 50% full, then the fee stays the same. And the key insight here is that the fee at the next epoch, or at the next block, depends on the current fee and the, let's say, random block usage. And I'm calling it random because there's a lot of things, sorry. There's a lot of parameters that inform how people are using this, depending on demand and things of that sort. Okay, and the second part of review, really quickly, it's on martingale pricing. So martingale pricing is this piece on derivative pricing literature that states that if you want to price a derivative or an option, and certain assumptions are met, such as an efficient market hypothesis and stuff like that, and this is an option that has some payoff that depends on BT, in this case, the base fee, as well as some other parameters, well, the price of this option that expires in the future is just the expected payoff discounted by some factor. And this expectation here, you can understand it as an expectation over all possible paths that the base fee can take, which in turn induce a different value for this payoff function. And okay, so how do we compute this complicated looking thing? Well, this is an expectation. Expectation is just an average if you don't think about it too hard. So this expectation here, we can approximate with this Monte Carlo estimate that we have here, where BTN is a simulation of this base fee price dynamic, which we then evaluate the payoff at some future time, right? So the main idea is you simulate base fees or parts of the base fee many, many times. For each of those, you compute the payoff, and then you take the average. Nothing too crazy. So the name of the game and the focus of the methodology is on trying to create a method or a way of simulating these paths BFT. Okay, and how do we did that? Well, we rely upon three main assumptions. The first one is that the block usage is x of t is a random process, and again, we assume it's random because we cannot always predict all levels of demand at a given price and things of that sort. There's, I don't know if someone dropped a very hot NFT collection, things like that, there's going to be extra demand than as per usual. The second assumption is a little bit technical, but it's Markovianity. It basically assumes that x of t, the relative gas usage, at the current epoch only depends on the gas usage at the previous epoch. And while this might seem technical and kind of esoteric, there is some evidence that it holds true, right? So like if we look at the autocorrelation of x of t, so like how does x of t depends on its past history, we can see here that it decays rather quickly, right? That it depends a little bit on its previous value, but it doesn't depend much on the previous ones, okay? And the third assumption is that of stationarity, meaning that the underlying relationship between the base fee and the block usage is stable over time, meaning that there's not going to be any big changes in how demand is distributed, or if we knew this demand distribution, it's sort of fixed over time. So this doesn't exclude the fact that there can be peaks in demand for whatever reason. It just assumes that these peaks occur with the same probability, which I think is also quite reasonable. So the core idea here is to come up with a model that for the probability of the next block's usage given the current fee, which I'm denoting here by this conditional probability distribution, P of xt given Bt, which if we know how to access that, we are able to simulate the entire fee evolution. So, okay, so the crux is, okay, how do we learn this relationship, this conditional distribution, P of x of t given Bt? Well, what we did was looking not at the conditional, but at the joint distribution. So P of x of t and Bt, the probability of these things occurring together. So this is what this probability distribution looks like in practice, well, of the log Bt and xt. And as you can see, it's multimodal. It has regions. I don't know if you can see it from there, but it has regions with smaller modes. There's this concentration here at 1, meaning that even if the base fee is high, you still have a non-zero probability of sending a very full block. So what we did was we collected historical data points of log base fee and block usage. We're doing log base fee for numerical stability reasons. And once we had all that data, and based on our assumptions, we fit a Gaussian mixture model. So basically, we approximate this with a combination of Gaussians to estimate this joint distribution. And then once we have this whole thing, we're able to sample from the conditional. And the way that we do it is, well, this object here, the way that you read it is that for any B of t, for any particular realization of this value, this becomes a probability distribution. So this is equivalent to slicing this figure here, or at any vertical point, and every time that you slice it, it creates its own probability distribution. So you slice it, and then you sample from it. And that's basically the algorithm that we did. So if you want to generate a single path of length capital T, what you do is starting from some base fee B0, you cut this distribution that I was just showing. You sample from the resulting probability distribution. You sample the relative gas usage, and based on that, you apply the EIP 1559 rule and obtain the base fee at the next epoch, and then you repeat that many, many times. So how does this look like in practice? Well, just like so. So here we have historical data in blue, which was the first figure that I was showing, and simulated data in red. So this data we obtained with this algorithm that I was just describing. And as you can see, it's able to capture several features that you have from here, such as range, volatility, things of this sort. And okay, so we know how to generate one path. If we know how to generate one path, we do that multiple times, and we can generate multiple paths. And with that, we can price the option, right? So the whole algorithm to pricing the option is using Monte Carlo methods, as in generating thousands of independent future paths with the previous algorithm. For each path, we compute the payoff at expiration. We compute the average of these payoffs and then discount it back, and that gives us our price. And yeah, just to give an example, we implemented our methodology. We compared it to this other method, this Ornstein-Uhlenbeck process from a competing methodology. And they both give somewhat similar results. So we got like 1.46, about 14 Gwei, and they got 23 Gwei, so not that different, but there's still a difference. And where does this difference come from? Well, I would argue that it comes from the fact that our model is more expressive. So if we look at these two simulations here, this is the one that we have, and this is the one from the competing methodology. So how do we interpret this? So this region in pink, you can understand as the standard deviation of all the simulations that we generated, right? So notice that it has like this big cone of possible paths, right? So you can think of a path being like something around here, right? So it has like a larger region where this base fee can be. Meanwhile, this competing methodology, because it's using this mean reverting process, it oscillates around a given number, and as such is only able to generate price trajectories on this very narrow band. So because of that, it is likely giving you a wrong price. Okay, so what are the practical implications of this? Well, this is just a pricing methodology, but it can help hedging as validators, roll-up operators, DeFi protocols can finally hedge their exposure to transaction cost volatility. It can lead to new financial products, and furthermore, it can lead to greater stability. So in terms of future research, how can we take this further? Just to reiterate the point, this was just on the pricing part, but there's still a few things missing, right? So the first one is productization, right? So we know how to price them, but then how can we enforce at the protocol level or at the product level or at the EIP level, the delivery of the block space, of the future block space, and how do we actually compute this efficiently on chain? Because it's Monte Carlo is probably not the best thing to do, not the most efficient thing to do on chain, so that's definitely an interesting research direction. Another interesting path is to look deeper into the approximation of this joint probability distribution, or learning this transition kernel, this conditional distribution, as well as using more computationally efficient methodologies, so this can be implemented on chain, or even trying to see if by some Laplace type of transform or some other analytical methods, one can come up to a closed form solution of this. Okay, so just a quick recap and some conclusions. So yeah, we discussed that gas fee volatility is a significant barrier to blockchain adoption. We introduced a novel pricing methodology that directly incorporates the AP 1559 mechanism. This mechanism is based on a Markov chain framework and learns from historical data and the IP 1559 dynamics. And in our view, this results in a more realistic simulation of the base fee, which can lead to more accurate prices. And this work can, lay the foundations for a new class of financial instruments to manage risk in decentralized ecosystems. Here's the paper if you wanna take a read at it. And yeah, that's it for me. Thank you.
Thanks so much, JP. This was amazing. Yeah, we saw two really very cool, promising, exciting approaches to solve key problems in crypto. That's our starting point for the TE Unplugged conversation. I'm just checking. Chris, are you ready to go? All right, let's go. So please come on stage. Chris Paruk, founder of the Token Engineering Labs And also, William, George, please come on stage again. Just checking the mics. Should be Let's go. Let's give them a warm welcome for the last TE Unplugged session.
Thank you, guys. I'm sorry, but you need to share one of the microphones because we only have two. Thank you so much for your presentations. I really appreciate your very formal and also very thorough content. Let's talk about the future and let's talk about the accuracy of predicting it. So you both mentioned mechanisms or systems or protocols where we are interested in looking at how things, prices or events, outcomes of events will evolve in the future and how we can credibly assess their outcome. JP, what you started with is a model of pricing options for gas, for infrastructure. How do you see the industry and where do you feel those predictions could be very influential in designing key new markets or new market mechanisms? What is the gap between today's development and real case applications in practice? And where do you think, what do you think is missing so that we can reliably build high-paced, high-accuracy protocols that would credibly leverage your research output?
Yeah, no, that's a really good question. So, I mean, let's start with utility. I think being able to having like derivatives on block space markets, that can be massive for like inclusion list, for guaranteeing execution, for MEV. It can really hedge that, so it can make it more efficient. But it can become its own thing as well. I mean, like options exist as a way of hedging, but it's probably one of the most degenerate things that you can do on the internet if you go on Wall Street bets. So it can create its own thing on that end. Now, what's missing? So I think being able to price them accurately is important because you that price is a measure of the risk that you're willing to take. So that price needs to be accurate, otherwise you might be overestimating or underestimating your risk. But as I was mentioning in my talk, I think there's two specific parts that maybe we can explore a little bit deeper. The first one is, okay, how do we compute this on chain, right? Because these are not like simple computations. This will be expensive to do. You need to do Monte Carlo. Maybe you can do it distributively. Maybe you can do like some fancier type of Monte Carlo as a multi-level Monte Carlo or something like that. But it's still expensive. So like trying to come up with methodologies to reduce that cost, it's definitely important. And the second one, which is probably the most crucial, is creating the specifics of the assignment of the option. So if I'm a contract holder, right? If I own an option that you sold to me, and you are someone who a block builder, then I need to make sure that my transaction will be included when I want it to be included. And that part is definitely not trivial. But I think if we only solve those two very difficult problems, it will be it can lead to a huge market.
And can you talk me through how the situation is today? So do those option markets even exist, or is this just a theoretical concept that you're exploring? And
no, so I know that there have been protocols that have attempted to do this. I don't remember exactly why they're not alive anymore, or if they're alive anymore. But it's definitely not new. But yeah, I think there's multiple factors to it. So the first one is that pricing is not trivial, assigning is not trivial, and yeah, I wouldn't know too well how they are actively handling this. If it's like a private set of executions or stuff like that, I don't know. I think it might be one of those things that might be easier to fix at the protocol level or at the chain level, just because it can become a terrible coordination problem. Or you have an option that is not that you exercise at a specific block, but you exercise at a specific window. So, like, I don't know, if you propose 30% of blocks, I know that with high probability, in, I don't know, a space of 300 blocks, you would have proposed at least around 100 of them, right? So maybe if you take this into account, like this window into account, it might become a little bit easier to implement. But then there's a trade-off that the pricing of an instrument like that becomes a little bit trickier. But
right. So the concepts that you explore in theory, there might need some further additional steps to be iterated over so that you can actually make the mechanism realizable in practice, right?
Exactly.
Okay, so let's talk a little bit more about that. But before we do that, maybe please hand over the microphone to William. I would like to frankly kind of have a discussion with you about the process of developing, conceptualizing, and exploring the mechanisms that you propose. Given that the mechanisms that you propose are anchored in a particular protocol or a particular use case that you want to develop them for, but you draw your knowledge from a rich body of literature, specifically peer prediction or information aggregation, and you alluded to this in your talk at the end, in the conclusion, but also at the beginning, that there are many different forms of sources that you could use and different inspirations that you could use in order to start your design process or start your mechanism exploration journey, so to say, right? So if you could help us a little bit maybe, and also the audience, to understand, like, how is it that when you start with a particular target design of a mechanism, how do you reach out or reach back to literature and try to anchor the specific points that you're interested in into an actual mechanism design? And based off that, we can...
Sure, thanks. Yeah, so for drawing from peer prediction, this is something that's been on our radar for years. You know, I've been working on the Claros protocol since 2018, and like, you know, very early on, like, people giving us feedback, like academics and such, were like, oh, are you aware of all these peer prediction mechanisms? And I look at that, you know, like, my reaction was, well, it doesn't seem very collusion resistant. You know, it's interesting, but like, it sort of like filed it in the back of my mind. It's like, I don't see immediately how we can use this. And then for this specific mechanism that I'm working on now, relating to try to like reduce risk for our, you know, participants in categories of disputes where you have really unbalanced like rates at which participants win. Like, my inspiration came from the people, like our users complaining on Telegram that the deposits are really high, and you know, I'm not comfortable with this level of risk. So you know, like at that point, it's like thinking, okay, like what kinds of, like, I have a new problem that I'm trying to solve that, you know, I wasn't necessarily on my radar before. How can we adopt the mechanism? What can we do? And at that point, somehow, you know, it triggered something in the back of my mind. It's like, oh, you know, like maybe you can draw something from like this peer prediction stuff that, you know, is compatible with our collusion resistance assumptions. So, you know, that's sort of the, you know, the origin of this mechanism. Generally, you know, listening to your community and like trying to like get a sense of how people are actually using the protocol, whilst at the same time, you know, thinking of all the possible attacks and, you know, evolving from there.
That's interesting. Okay. One of the main differences between the solutions that you propose or the topics that you talk about, at least from the point where I stand, is that, William, you are talking about very specific, discrete, and influential events that people, you know, have predictions about or votings on or want to resolve, right? And in your case, JP, we are more on a minuscule scale where we are talking about pricing gas options, where those changes or like those events happen more frequently, and therefore you have much more, let's say, flexibility, or it's not so impactful what happens in a particular time step, right? So when we talk about risk in this context, right, for you, obviously the measure that you're looking at is volatility, right, which you're trying to assess. What about you, William? I mean, like, if you say people are unsatisfied with the risk of participating in something like that,
yep.
I imagine that if you have kind of like a legal resolution and you need jurors to vote on something, this is a lifetime event potentially, right? So you don't really have the time or the chance to say, okay, screw the first outcome, let's replay the game and play another time, right? So how can you manage risk in your situation? This is the question.
Yeah. So, like from so there are two perspectives here. There are perspectives to the parties to the dispute. There are also the perspectives of the jurors. I mean, the jurors, in theory, they should be relatively sophisticated actors. You know, they're doing this as like a repeat game. They, you know, they're members of a community that like they know they're getting, you know, it's like gig work to be a dispute resolver. Like presumably they're going to do more than one dispute, and like they realize there are these, you know, these risks you might be wrong in any given dispute. But like particularly when the deposits are really high, you know, even if it's like the game is repeated, like one really big loss they might not be able to recover from. Like normally the like this is a lifetime event, I'm having you know, like my dispute is being resolved, would probably be from the party's perspective. The people who have the, you know, are the opposing parties in a dispute. However, like, you know, you want to provide acceptable risks for everyone involved. You know, but yeah, you can't like iterate a whole lot when the protocol is live. You can just try to be better, you know, in the future. Like in terms of having like the continuous versus the discrete, like I feel that you probably have like much more data to work with than we necessarily do. You know, we have, you know, thousands of disputes historically, and that gives us a certain amount of data to work with. But like particularly stuff like risk aversion is not something that like is really visible in the data. Like you don't know what, you know, like the only response that, you know, we see in the data to like jurors being risk averse is that they stopped being jurors and they left. But they could also like stop being jurors for all kinds of other reasons. So the data is like really noisy, and I feel like a lot more of validation in this kind of setting is to have like surveys and maybe lab experiments. We haven't done those yet for this mechanism. We've done some lab experiments for other mechanisms we've considered. Our PhD student we're working with, Yan, who's sitting in the audience, has organized a bunch of lab experiments for, you know, to test like how do people respond to different mechanisms. And I think that might be particularly relevant here, you know, given that like risk aversion is a personal thing.
Okay, but this ties quite a bit into the perception of the mechanism, right, by the participating parties. It connects with behavioral economics, for example, you know, interpretations of specifications or mechanism definitions. How about taking one idea that JP proposed today and implementing an option market for dispute resolution outcomes? Is this something that like you think could work? I mean, by doing that, you could externalize the volatility to some extent. You can, you know, try to cap it by externalizing the risk of an outcome to parties who are willing to take the risk.
Yeah, so in terms of having an option market for dispute for like the dispute outcomes, like, you know, like some independent market where you're like, you know, you can hedge against like, you know, Alice winning or John winning. I feel for the parties to disputes that could potentially be valuable, and that I mean on some form that would be kind of like a version of settlement between the parties, assuming those are the ones participating in the market, and that they like, you know, agree to. Maybe there's still some underlying dispute going on, but they agree to, you know, like even if like John wins, Alice gets paid out something because she bought the like John option. Like the jurors' incentives, I consider this like a challenge in that you know, it like gets back to these questions of lazy strategies, and the jurors by participating in an option market can dilute their incentives and be like, well, you know, like. Yeah, there's this huge deposit that I might get slashed with, like, you know, hard cases or whatever that's discouraging from being a lazy participant. But what if I just, like, you know, in addition to using whatever in-game incentives I have, I'm also like speculating on the options market. It becomes harder to disincentivize the lazy strategies. In like an extreme advantage situation, you can imagine that like the right bundle of juror incentives plus options always gets you out to a constant payout of whatever the average fees are, whether you're doing any effort or not. And how do you disincentivize this? We've considered as a module in version 2 of Claros, which is in the process of being released. This module isn't live yet. Having like a juror misbehavior court where jurors can be slashed basically for certain kinds of behavior. If people realize the jurors are doing something, that would create secondary disputes. People can challenge them, and then the other jurors can vote on whether or not they broke the juror code. And this is something that like I would consider like anti-juror behavior, where if you're a juror, you should not be speculating on an options market on the case.
Okay, so is the argument that you're making here is that in some cases, specifically for dispute resolution, for example, it's very good to have high-stake games so that you get the incentives right and people behave honestly.
Yeah.
And for other cases where, for example, we talk about infrastructure, you would want to get the risk out of the way and have predictability of future pricing so that infrastructure that is built on top of this can reliably understand the costs and risk. So that's very interesting. Okay, cool. Perfect. So, JP, back to you. William, like one of the biggest points that he was making is working under adversarial conditions. What about your model? I mean, have you investigated this? Have you been looking into this? Have you been looking into pricing scenarios where people might be adversarial in this case? Like, how would this just change the volatility, or is there something more to it?
That's an excellent question, and it really goes like to the depth of the theory, because when you're pricing options, at least when you're pricing options with under the equivalent under the martingale methodology, one of the underlying assumptions is that you have an efficient market. And an efficient market sort of precludes the fact that there are adversaries or that there are arbitrage opportunities and things of that sort. So you're kind of working on a nice, let's say, environment. So yeah, I mean, I think you could map it back to an adversarial scenario, but you would need to sort of understand what is this change of measure between like the risk-free and the adversarial one, and it's not always easy. It's not always easy to do. So, I mean, I guess what I'm trying to say is, I guess pen and paper you could do it, but ultimately you will need to come up with either like a model for this adversarial component or something like that, and I think once you start doing that, the model might start losing some validity, because you're putting more and more assumptions to it.
Okay, so what would be even the adversarial behaviors in your environment? Is this like someone who is intentionally trying to spike the gas price?
Yeah, so someone who just, I don't know, sends an empty block, or that, like if in the hypothetical scenario where there's like a controlling entity for the blocks, right? That entity decides that that they want the price to go up because whatever reason, as opposed to let demand forces play with it. It becomes super messy. I don't know if it can be done. Yeah, exactly.
But isn't grieving something that you could apply to this scenario? I mean, like just having someone who is trying to just.
Yeah, interestingly, like there have been like a variety of people who've written academic papers on griefing since Vitalik sort of introduced this version of this concept in the blog post. And one of the papers, in fact, maybe Vitalik wrote this, is on discouragement attacks on proof of work systems, where the idea was that like you mine this is related, maybe not exactly the same thing. If you're like a proof of work miner, you mine beyond what it makes sense for you to mine. You like mine at a loss, so that the difficulty adjusts and goes up, and all the other miners are also being forced to mine at a loss, and they eventually just leave the system. And I could certainly imagine something like that happening with the gas market, where you're trying to like push out competitors. Maybe you have a censorship attack. Part of the like issue with griefing is that it's defined in terms of the in-game incentives people have, where it's like, okay, like they're doing me harm and they're taking a loss, but you never really know what people's external incentives are. Like maybe they're trying to sabotage you because you're some kind of competitor. Maybe they're doing a gas attack because there's like their competitor wants to get a transaction in and they're particularly trying to censor them by raising the gas. So yeah, certainly.
But this is also a threat to the security of the system, right? Because if you crowd out competitors or a multitude of other validators, you can take over control.
Yeah. I mean, like ideally, for the discouragement attack where you like artificially raise the difficulty of the network, or like the gas is too high or something, and people have left because they're frustrated and they're losing money for a long period of time. Once you're in a monopolistic position and you like go back to normal equilibrium where you're not at a loss anymore, the people will come back. But in reality, like there's friction, and your competitors might not come back.
Okay, so you're saying that attack is only as long effective as people are actually working at loss, and afterwards they might.
Yeah, I mean it depends on the attack, but that the specific sort of discouragement attack on proof of networks is like that.
Perfect. Let's talk about implementation and practical translation of those concepts into real world. Okay, so what you have laid out is like an academic paper, a model that is helping us to understand very deeply how those mechanisms work and how gas options could be priced. Is this something that needs additional attention when we talk about blockchain systems? Or is this something where we say, from this theoretical model, it's enough for us to understand how we can build the EAP 1599 mechanism, and it's good enough for us to proceed? Or do we have to make any adaptations to the theory or any adaptations to the understanding when we really want to build blockchain protocols out of it?
No, so I think the theory doesn't need to be adjusted, but it could definitely be refined. As in, again, it's a pricing methodology, right? So you can come up with either a more accurate pricing or a more a faster way of obtaining that number, right? But the theory is there. I think that the complicated part is moving from, okay, I have this oracle that gives me a price of how much this thing should be, moving from that to the actual set of rules that you would implement on a blockchain or on a protocol to make this happen. And it's tricky in the sense that, I mean, to me the easiest way is if you sort of do it at the protocol level, like if it's a default, you sort of pay, like the one that sells you the option is the blockchain, and then the one who receives the payment at the end is the block builder. But that of course that's not an easy change to make, just because it involves a lot of social coordination, plus lots of engineering work and things of this sort. But or maybe at the I'm trying to think whether you can do it at the app level. Maybe at the app chain level you can do it a little bit more easily. But I would need to give that more thought. But yeah. To answer your original question, I think the theory is there. It's sufficiently broad to cover, the pricing part. But then there's the implementation part, which is
right.
Tricky.
So we would expect a proper insurance market to emerge on top of block production.
Yeah, you could have that. Yeah, and it would be, yeah, that would be a canonical use case of this, like gas insurance. So. I don't know, like few years ago when USDC was depegging, I had a few USDC, not that much, but I tried to change it, and I don't know, I spent like $500 on transaction fees. If that existed, it would have been, the usual amount.
was this the reason for you to start thinking
Exactly.
about? Okay.
That's my origin story.
Okay, and now when you have it, like, what is the plan ahead? So, like, are you the one to trigger this insurance market somehow?
Probably not, or maybe, I don't know.
Okay.
But no, I mean, I think I would like to dive deeper into the mechanistic part of how to how can this be implemented. Maybe not like from the entrepreneurial part, but from the mechanistic part of
Right.
hey, this is what you need to do at the protocol level so that this can be realized. And if there's enough buy-in, then yeah, we can take it from there.
That's actually a very cool extension to like consensus mechanisms by integrating an option market on top of it. Very nice, yeah. William, your research is much closer to the way how your protocol operates, right? So like the distance from whiteboard to implementation, it's probably going through multiple iteration cycles in-house, but how do you see, like how much cuts do you need to make to the stylized results that you have on paper when you go towards an implementation at Claros?
Yeah, I mean, like, this mechanism can be implemented, like, already. There's a bit of a question of, like, you maybe want to do more experiments, you know, as I mentioned sort of earlier, maybe there might be behavioral experiments in the future. Maybe there's some slightly different version of this mechanism, which is more appropriate. Like, more reflection can be done, but, like this mechanism is not far off from the kinds of mechanisms that we have and can deploy, and it could be deployed as is. So the current version of Claros, which is being developed, the V2 that we've been working on, is sort of modular in its design, so that you can deploy different incentive and voting rules that are used for different kinds of cases, and you know we can identify that okay, in these kinds of cases you have like really unbalanced rates at which the people win. So this is like an appropriate use case for the peer prediction dispute kit, and you know like the devs have to code that dispute kit, but like there's not a very long path from whiteboard to eventually being able to be deployed.
And when you say this mechanism can be implemented, is this, I mean, like the criticism, is it that it is difficult to do so, or is it that you say maybe like it's a mechanism that might not find a strong adoption because it's just too niche or too complicated, or like where is the bottleneck really? Is it in the usage, or is it more in the technical challenges of implementation?
Yeah, I don't think for this dispute kit there's like usage will be the problem. We've identified like this has been like an issue in a variety of the categories of cases we've had up to this point. So I think that this like set of incentives will have a home. So maybe some of the other dispute kits that I've thought about are maybe a bit more niche. We'll see if they see the light of day. Mostly it's just like the bottleneck is just the devs' time, and we have a lot of exciting projects that people are working on deploying. There's an order of priority, like the dispute kits which are being deployed for V2 now are like higher priorities, but like I don't feel this one is too far down the list.
Okay, let's talk about data. Sorry.
No, if I may interrupt. No, that I was just going to tell to Will that I think it has a nice application on validation markets. So like I'm doing something, someone is checking me to do it, or a committee is checking that I did the job, right? But for the committee to check that I did the job, it costs them some effort, some compute or whatever. So if they're lazy, they can always be lazy, and they just say that I did the job based on my reputation or my score or whatever, or my history, but that becomes poor UX like very quickly. So if you have like these mechanisms to keep them in check and keep let's say the prover in check, that's I think that's very valuable, and it has applications across many different things.
Perfect. Let's talk about data availability and market depth. You mentioned that it's quite easy for you to observe, obviously, like what's happening on the gas markets, and you have all the data at your disposal, which probably makes the models or the predictions that you make more accurate, or like more closer to future outcomes. how does it work with, like how accurate are your assessments when you are lacking this data availability, right? And this might be even more prominent in your case where you have probably less participation, more specific events, and so on. So how can we make the prediction models more accurate given that we have limitations with respect to data availability?
So in my case, you definitely need data. Maybe you don't need the most recent data, but you need two types of data. The first one is you need the current base fee and the gas usage. You cannot do without that. That's just one data point. That's not too bad, and it's at the header of the block. And if you assume, which is one of the assumptions that I'm working on, that the distribution, this joint distribution of relative usage and base fee, that it doesn't change over time, the distribution, then I mean, basically, like if usage patterns are the same today as they were 1 year ago, like there was no big EIP that collapsed gas cost or any major upgrades, then it's fine, right? Because you are simulating from this snapshot of what this joint distribution looks like, but because it's static, it's the same now as it was before. So yeah, you don't need to keep adding to it. At some point, you're going to have too much data, and it becomes a computational problem. So yeah, but there's that specific caveat. If this distribution were to change, or if a protocol upgrade were to happen, then this assumption is not valid anymore, and you need to collect again sufficient data so that you can construct this joint distribution.
How do you deal with limited data?
Yeah, I mean, a variety of ways. You can try to like use mechanisms and prove theorems that are, you know, like that are strong even in the absence of like lots of assumptions about the data. Like the theorem that I had on at the end of my talk said that the average deposits went down or something, that were like the average slashing went down as long as, and you're better as long as you have risk-averse participants. How risk-averse? It doesn't matter. As long as there's sort of like more, lambda bigger than 1, they're helped by this mechanism. You don't necessarily know if they're helped enough for it to be worthwhile for them to participate in the protocol, but it's like you haven't done harm, or you've made things no worse. So like you can try to tune parameters when you need to tune parameters in ways that are conservative. However, that can, lead to, in like version 1, when we're trying to deal with lazy strategies, and our approach to doing that is to have really high deposits. If you are conservative and you're like, okay, I don't have enough data, I'm going to err on the side of like even higher deposits because I really want to prevent the lazy strategies. I mean, that can make the user experience even worse. Like there can be, the lack of data can certainly be a problem. There's only so much data that you can get on chain from these very discrete events. Surveys and like lab studies can help. It's a toolbox of different approaches.
You mentioned in your presentation also that one way to think about those things is to be very conservative with parameter tuning, right? Yep. So is it a good strategy to say, like, as long as you don't have enough information, you are more conservative, even more conservative, you are more punishing to people who misbehave or who, and then you kind of like narrow down the band for parameters so that you kind of like let the system flow when you learn about like true behaviors or truth.
Yeah, I mean, there are trade-offs here, and it sort of depends on where you land on the trade-offs. Like the parameter tuning that I described, trying to discourage lazy strategies of having the problem that you're raising deposits on the users, like ultimately is a trade-off between the parties to the disputes, good experience, and the like jurors' good experience as like two sides of the dispute resolution market, the like buyers of dispute resolution and the sellers of dispute resolution. The jurors are repeat actors where, like if they're having a bad experience on like one case, hopefully it'll average out, again with large deposits, maybe it doesn't average out enough for them. The parties, they only have one dispute. If they have a bad experience, it's might hurt the overall credibility of the protocol because they're more likely to not have positive experiences that average out. They'll write angry criticisms, and ultimately, particularly if you just fall into an equilibrium where it's just everyone is using a lazy strategy, that's really bad. Maybe on something like this, we've been really conservative in the parameters we've been proposing and the governance has been voting on, because you really don't want people to fall into lazy strategies. On some other situation, maybe you can be less conservative, or you'd be on a different spot on a trade-off anyway.
How far away do you think are we, or are you guys, from reaching the same accuracy as Polymarket, for example, in the case where they say they have the outcomes of presidential elections even ahead of the polls, right? Even of the outcome polls. If you want to find up-to-date, accurate, the quickest and fastest information on the internet, you are very keen to check with Polymarket to see how did the event end? What is happening, right? Do you think that Kleros can achieve this level of credibility, accuracy, and kind of position itself as the dispute resolution oracle?
Yeah, I'd say that there's somewhat different goals here. In that, for something like a presidential election market on Polymarket, they have tons of people who are have a pre-existing interest in that want for whatever reason to participate in this market. Yeah, 538. Yeah, and there are a lot of people who have an independent interest in this question that are maybe people are almost to the point of neurosis where it's you anxiety in advance of an important election. There's no lack of interest in those questions, or some of at least the high profile questions. Kleros was really designed for having questions that disputes that maybe require a lot of subjective effort. They take time, of the jurors to resolve, and that you need to compensate them because they would not necessarily have been interested in solving this dispute task. Nobody cares about the dispute between Alice and John except for Alice and John, and you need the gig work kind of aspects to encourage people to come and solve their task in a way that Polymarket, they already have people who are interested in this task. So they can have a huge market where thousands or more people are speculating. Where Kleros is really designed for okay, I have these 3 random jurors. They were drawn. Their task is to solve this question. Maybe there's an appeal to 7 jurors, and slide and up the chain of higher appeals. But ultimately, you want to be efficient in people's time because it's a task for the jurors. It's a work thing. The cost of dispute resolution is something you need to be cognizant of.
How is it actually at the inception? So, I mean, did you have a cold start with respect to qualified jurors, or did you have difficulties to find appropriate jurors or people to guide those resolutions, or has this improved over time, or is it something that you have already baked into the protocol from the start? What was the bootstrapping?
Yeah, so who the jurors are is something that we've obviously thought a lot about. In version 1, we rely entirely on cryptoeconomic mechanisms to try to have jurors self-sort themselves into being qualified for cases. This whole idea that if you are bad at your job, bad at your task, and you're losing money as a juror, you'll eventually ideally leave because it's unprofitable for you. Should lead people to self-select. There's a hierarchy of different types of cases. People stake to be selected in cases that are of different categories, with the idea that people should stake to be in categories that they're good at. In version 2, we've explored a lot about how you can have more formal qualifications, how people can have certain SBTs that are say that I have some, I have I have a certification from the Token Engineering Academy, or I got some, specific some online school or whatever. I've was that ECC that state to some aspect of my experience, maybe that I have some SBT saying I'm an expert in whatever, that I have some relevant case for. I'm an aspect in, I'm an expert in JavaScript development or whatever. And then you can require that to be drawn in certain cases. ultimately, like how many jurors we have in different kinds of cases, like a lot of the cases we've had so far have been kind of like blockchain-y native kinds of things, and the qualifications people need have been sort of sophistication and like ease of use with crypto, which ultimately, if you're using a crypto platform, you probably already have anyway. As you branch out to like more real-world disputes, maybe the like SPTs and the formal qualifications are going to be more important.
And what is more relevant? Is it the collusion resistance of the mechanism, for example, like how the mechanism works, or is it more the community that you have of people participating in the system, or is there kind of like equally weight between?
Like everything's important. Like you need the mechanism to be resistant to all kinds of attacks, including collusion attacks, because if you fall into a bad equilibrium, you're not going to be credible as a dispute resolution provider. Does that sort of get to your question? Or like?
Yeah, I mean, I think that by defining the mechanism in a way, you will secure some properties, right? And then you will make sure that regardless who votes, this specific outcome will have, those properties as well.
Yeah.
But depending on the quality of the votes, it will probably be kind of crucial on whom you let to vote on particular things, right?
Mm-hmm. Yeah, certainly. Like one aspect on like the trade-off between collusion resistance and community, we depend heavily on our appeal system, so this might be a bit tangential to the question, individual jurors in our panel, in a given panel, might go to our Telegram group where, for in many cases, as I was saying, that there's not a lot of independent interest. People might not care about like an individual case, but sometimes people are arguing about cases on Telegram because people are interested, even if they're not a juror. And like, how do you like draw the line between what is collusion? If like people are talking about the jurors are talking about the case on Telegram, like that kind of breaks away from this notion of the Schelling point where they're like coordinating in the absence of communication. Like our way of thinking about that is that because you have an appeal and like you can go to like larger and larger panels of jurors who may not have been selected yet, they may not be following this, they may not even be staked, as jurors at the moment. You can have like a balance between like deliberation, where people are talking, jurors among each other on Telegram, other community members, and while still having like, defenses against unhealthy collusion.
Perfect. We have 3 minutes left. Closing remarks or questions from the audience?
Also that, right? No need for applause. So I work at Kleros, and I have worked with William for like 7 years now. We have discussed this many, many times. One thing is worth mentioning that it didn't come up in the talk is that some of the ideas for the modeling of the mechanism come from history, like the ancient Greek courts, private system of dispute resolution in England, 18th century, the Iceland, the system. One thing, and then the other is that lots of things, and this is from a commentary to which you can react. We have lots of ideas of what we can put into the court system to make it more efficient, to be cooler, like prediction markets, agents doing prediction markets about what is going to be the outcome of a case. But then when you go like to the customers, to the parties that will be subject to the decisions of this system, like traditional governments, insurance companies like MetLife that use it for resolving disputes between users and the company, fintech users, they could see those type of mechanisms like too weird and too far away from what they expect from like a dispute resolution system, right? So there's a lot of expectation of how this should work, even if it comes at the cost of sacrificing some of these cool ideas that we had over time. I know maybe you want to react to this.
Yeah, so just to like give context for your comments on like, Iceland and such, like there are these historical examples of financialized dispute resolution. So one of the things people complain about with Kleros, like potential users and integrators, is it's like weird that like the jurors, like they have financial interests and they're getting micro payments that depend on whether they're like right or not. There's a history of financialized justice, where like in 17th century England and Saga era Iceland and other places, like prosecutors weren't public, and like individuals would do this job in exchange for bounties. So like, you know, it's maybe not like the most natural like dispute resolution platform when you have access to modern courts and modern, you know, jurisdictions. But when you're trying to come up with something that like works on the blockchain, is transnational, is like good and affordable for micro disputes between people across borders, you know, it's not so weird that you have financial mechanisms. Like for people reacting negatively to like the weirdest ideas we've had, I mean, ultimately, I feel that like version 1 was very weird from people's perspectives, and as we deploy more modules, like we're trying to like come up with things that are crypto-economically resistant and like, you know, sound while being more normal. Like gradually, the court is becoming closer to like a Web 2 like experience. I don't know, you might have context on like history of your.
But is it important for the participants to understand how it works under the hood? I mean, like all the mathematics that you've shown today, I mean, they're very impressive. Like, is it kind of good enough to say we have it thought through and we have the proof that it works, but you don't need to understand it, you just need to rely on kind of like the reputation of the system that we have, that this is a good protocol? Probably yes, right?
Yeah, I mean, I guess it depends on the person who's deciding whether or not they want to use this protocol. You know, for some people, yes. Other people, you know, like some people will be more convinced by like a mathematical proof. Other people will be convinced by a track record, you know, of like success in, you know, previous cases. Depends.
All right. Cool. Any other questions from the audience?
Anybody else?
If not, then final remarks, closing statement.
I don't know. Like this is a good conversation. Like ultimately, like these ideas that I presented in my talk are fairly preliminary. Like you know, eventually they may be further developed before they see, you know, light of day as a Claros dispute kit. But I'd be interested to see if like the evolution of peer prediction ideas in this space. Like it's a really cool, rich field that is being underutilized because it doesn't fit so well with our attack models. But like, you know, maybe if you squint and look right, you know, you can come up with something that like, you know, can be adapted, or like, you know, you turn it around and use it a different way that can add value.
Cool. JP?
Yeah, no, I mean, not too many finalizing remarks on my end. Just thanking you and Angela for having us. Super interesting stuff.
Thank you very much, William, JP. Thank you.
I think we all agree. Thanks so much. Thank you for being with us today for the token engineering track. I think this was such rich content throughout the day that I'm myself looking forward to watching the recordings. So enjoy EFCC. Thank you so much for coming. You can follow Token Engineering on Twitter, Talk Engineering. And I'd like to invite you to another session tomorrow. It's DAO and governance, starting at 10 at the Vision Room. And it's again about mechanism design, this time more tied to governance, exploring the latest, most exciting experiments around AI agents, machine learning, also prediction markets in the context of governance. So hope to see you there as well. And for now, have a great evening and thanks for coming again.